guys, welcome back to Rocket Gyan, my fellow space tubers. So today we have a very important and a very exciting and a very I just can go on saying about this mission and I won't finish. So today is the day when NASA's OSIRIS-REx spacecraft will touch down on asteroid Bennu and will collect the samples from it. And yes, if that is successful, then it will send it back to the Earth. So that's the thing, you can say the summary of the mission, which I said in this line, but we can have some details about it. The stream will be live. The actual means the actual touchdown will be live in around some minutes. But before that, we should know as in what we are going to see, right? What is it about? What this mission is about, and what can we expect from it? So here we are looking at it. So as you can see here, the mission is the OSIRIS-REx seeks answers to the question that the central human are that are central to the human experience. Where did we come from? What is our destiny? Okay, and can we change our destiny? Yeah, can we change our destiny? That's also the part of this mission. So guys, welcome back here, and who are here? John Doe says, okay, same here. Okay, why was it skipped? Hello, Kitty. Hi, Andre. Hi, Alex Bogdan. Okay, so hi, people. So let's just jump into it right now. So the mission objective, as you can see here, return and analyze a sample of Bennu's surface, which we'll be doing today. We won't be doing the return, but obviously the collection of the sample of the Bennu surface will be done. Map the asteroid, which they have already done, because this was launched way back in 2016. The spacecraft is in orbit of the asteroid Bennu for 2 years, mapping and studying everything. And after doing everything, analyzing it, studying it, today is the day when it will finally land, or you can say land. Yeah, in lame, you can say in simple language, I would say it will land on that asteroid and collect the sample. So he document the sample set, measure the orbit deviation. So that's the thing. So mission. Let's go and see the mission operations now. Uh, let's just see that happening. There is some problem with the connection. Oh, okay. So here we are. So here we are with the, I think it should load. Yeah, here we go. So as you can see, this is how the asteroid Bennu looks like. Okay, so it was launched from on Atlas 5 rocket on September 2016. It was launched and it orbited the sun for a year, and then on September 27 it uses Earth's gravitational field to change its trajectory to match that of Bennu's. Okay, so what is this means, what is this change in trajectory by using Earth? This is what we call gravity assist. Okay, we use the gravity of some planet to accelerate a spacecraft. So you must be thinking, how, what are you saying? Means how can a gravity accelerate a spacecraft without an experiments what do you say, exerting, yeah, exerting any force on it. So we know gravity is a force, and to understand how gravity assist work, just you can say, take this example. Tie one rock with a thread and just revolve around your head. Means, okay, just revolve it, not around your head, just revolve it, and then you can just leave it. It will just go tangent to the direction where in it was moving, right? It will just go, it won't stop there, it will go. That's what kind of thing happens in the gravity assist. When the orbital velocity is not achieved for a thing to stop the spacecraft, then it uses the gravity of the planet, which is, you can say, a string, and that which pushes it away, and hence it is accelerated. So that's what is the thing with this. And now what it will do, it has mapped the surface, everything is done. Now it will do, what will it will do, it will just touch the surface of the Bennu to retrieve a sample. So how it will retrieve the sample? The sampling arm will make the contact with the surface of Bennu for about 5 seconds, during which it will release a burst of nitrogen gas. So here is the thing, here is some mechanism which we call as reverse vacuum. Okay, as we know, space is all about vacuum, right? So what is this reverse vacuum? It is, yes, we are carrying the atmosphere or air with us. So nitrogen will be carried with us. It will just spray out the nitrogen, the blow away the nitrogen from its arm. I'll so show you what am I talking about. I think it will be here, and then it will be a clear picture to that. After that, when it will collect the sample, after that it will stay in the orbit for March 2021, because at that time the window opens for the Earth transfer. Okay, so at that time the window of, okay, there's some problem with the site. I don't know, is it down because of most of the traffic is coming around there, but should not happen, but it is happening. It is not the problem with my internet connection, but yeah. So hi everyone. So cannot wait to see this. To get great time to be alive. Yes, Louis Carter. Hello for New Zealand. Hi Millet. And why is it not working? I think there is some problem with the backend issue. No worries. I have something else also to make you see and maybe explain you. Hi Patrick. Hi Dark Lord. Howdy from the dark side. Okay. And hi Paul, absolutely amazing, thank you so much. And if you like my work, what I do, you can support me on the Patreon, link is in the description. And I oh, okay, so here we go, we are here, asteroid operation. So this was the timeline of the events which you are seeing here. Okay, this is the timeline of the events which you are seeing here. uh, Today we are here in this region, sample collection. Already 4 years have passed by, and it was studying going to the asteroid took 1 and 2 years, and then studying it took more 2 years, and now finally it will just go down and collect the sample, and then it will again stay in the orbit till March 2021, and then it will come back to Earth in March 2023. So it's a very long mission. So this is the approach phase. Okay, this should not be a thing of worry. Let's just skip this, and here we go. This is what the mechanism I was talking about. As you can say here in the GIF, it will just go, touch down the surface, release the nitrogen gas. Now what is happening, I am just explaining you. As you can see here, the nitrogen gas is blown here, and it comes here like in a cycle, as you can see, right? So when it blows and this cycle is achieved na, so what happened, the gravels, the loose sand or some boulders, small boulders, gets blown away and collected in these drums. As you can see here, in these drums it gets collected, and we can then have the sample. This is how it will do. No digging, nothing will be there. It's a very, you can say, engineering approach to solve a problem, rather than just digging in and collecting it. It's a very good thing which I found out, and I liked it very much. So now what is Osiris Rex acronym basically? And now again it will have some problem. Okay. Osiris Rex is nothing. You must be thinking Osiris Rex. Wow, what a name! But it has already you can see some scientific meaning to that. O means origins, SI means spectral interpretation, which it is doing, resource identification, security, and regolith explorer. So the meaning of the name is very, NASA has this habit. They just take the name and a beautiful name, and then somehow manage to make it as an acronym. So I like that very much. That's the thing. Now let's have a look at what Bennu is itself and why is it so interesting to us. So hi Manat Singh, hello from India. Yes, thank you so much for tuning in. You will just love this show. I'm pretty sure if you are uh, somewhat like me, who loves this space and everything. uh, Again the problem is same, backend issue. No worries. So we what we can do is we can have a look at this. Yes, the live view, you can say, of what is happening there. You can see it. This is the spacecraft, guys. This is how Osiris Rex looks like. So let me explain you everything from this view only, okay? So this is the spacecraft, how big it is, and everything. Let me just tell you. So this is tag. This is what will touch down and go. So as you can see here, this thing is uh, if you can see, I think you must be having some problem with the brightness issue. Let me see if I can. Oh yeah, here we go. So here we have the Osiris Rex spacecraft. You can see here. These are some instruments. These are some cameras, scientific instruments. This is the collection. Yeah. This one is the, I think, is the uh, sample return capsule in which the sample will be collected. And this is the Huygens antenna, and this is the part from which today's mission will be accomplished. So as you can see, this is already protruding out of the spacecraft. So what it will do is it will just go uh, demaneuver itself from the orbit and have a touchdown at the site. Now they had four sites selection for the collection of the spacecraft, and finally they chose Nightingale site, which is around in the polar North Pole region. And they have the backup side. If they have some problem with the Nightingale side, they have the backup side known as Osprey, and it is in the equator region. So this thing is totally autonomous, everything is good. And because the signal to reach this spacecraft takes around 18 and a half minutes. A signal from Earth to reach this spacecraft take 18 and a half minutes. So what we will be seeing today will be a past event which has already occurred, and we will have the telemetry after that, after 18 and a half minutes, and accordingly NASA will be simulating the thing, because we won't be having the live imagery, because it will be using a low gain antenna, which means you won't be having the live imagery. The you can say the data transfer speed is around 4 bits or 8 bits per second because of the low gain antenna. So what will happen is after it is everything is done, it will reach the orbit obviously, and then it will send the imagery to the NASA with the Huygens antenna, and then after some processing or what they will do, they will release the clip most probably. Okay, so that's the thing. And now this spacecraft, as you can see here, and this is the asteroid Bennu. If I just zoom in here, this is asteroid Bennu, and this is why we are going here. Let me just tell you why is this mission in place. There are three reasons. First of all, this asteroid Bennu is can tell about what happened in past of the solar system, because asteroids have those tendency. This is 4.5 billion years old asteroid. So after analyzing its content, its samples, we will have that thing in our mind. Okay, so that's the thing. Second most important thing, why we are going to this specific asteroid only, because it contains amino acids, carbons, amino acid, hydrocarbons, and we all know amino acid is the building block of life. So maybe it can also tell us about the origins of life, because we believe and we suspect that on Earth also the life was, you can say, life came from asteroids only. So we suspect that, and this could answer some of those questions. And third reason is that this thing is in collision trajectory towards Earth in around 2100, and the you can say the possibility of colliding it with the Earth is around 1 in 2000 or 3000. It is pretty low, but it comes really very close to Earth in every 6 years, and it is a near Earth object and potentially hazardous object. So we need to study it in order to avoid any potential colliding with the Earth. So they will be studying it, and hopefully, you can say, uh, then send a mission. If it is in future in collision trajectory with the Earth, they will send the NASA or any other space agency will send some mission to the Earth through this Bennu to change the trajectory of this asteroid. So this changing of trajectory is also being done in next year only. NASA will be launching one more satellite which will actually try to change the orbit of the asteroid. Means it will be a technical demonstration mission, but yeah, there is something about that. Okay, so let me more talk about this a little bit more. So as you can see, this is the tag, and this nitrogen cartridge, we say this in nitrogen cartridge has three parts. Means it can be used for three times. If one first attempt goes wrong, then it can go for the second and then for the third. So it has three attempts to do it correctly. Okay, so awesome presentation, great explanation. Nicholas says awesome presentation, great explanation, the mission and demonstrating which school was like this. Yeah, we all think like this only. Yeah, so what I do is I do this only on this channel, guys. If you are new to this channel, on this channel I cover all the space events, all the rocket launches that happen in the space industry, and you can say many other space related videos, rocket science related videos. And if you are kind of that kind of like guy who just want everything in one spot, you can just subscribe to our channel and support me on Patreon. It will really help me. I trust you, because uh, making all these things requires effort, and YouTube, as you all know, algorithm and everything does not provide sufficient funds. So it will be a great help if you can do that. So let just getting back to it. So it has three attempts, as I said. It has three attempts. Yeah. So that is one thing. What other thing is left? Yeah. So how it will, so there is one minimum criteria for the measurement of, you can see the weight of the sample. It should be greater than 60 grams. Okay. So whatever sample it will collect, it should be greater than 60 grams. So to ensure that, how will they measure weight in space? I mean, the weight is always measured because of some gravity. Here on Earth, the weight is measured because of gravity. Otherwise, we have mass, right? Weight is what? mg, mass into gravity, right? So otherwise we have just mass. If we don't have gravity, we just have mass. And to know what how much weight we have, how much you can say the sample we have collected, they have a very unique solution to that. What they will do is they will extend this arm. Okay, this will have the sample, and this spacecraft will itself rotate around its axis. So what it will tell is, it will be then after rotation, the NASA team will be able to measure the moment of inertia. So if you don't know moment of inertia, it is kind of like moment of inertia is like change in momentum only, like but in circular motion. What is change in momentum is nothing. When you just press the brakes, you just go in the forward direction, right? If you press the brakes of the car, you just go in the forward direction because you have momentum in the forward direction, and then you just apply brakes, and that's why you just keep going there. So that's what happens in the uh, rotation scenario also, when the spacecraft or the object is rotating. So because of that, what they will be able to measure, they will be able to measure moment of inertia, and because of that, they will be able to actually calculate how much sample they have collected with 20 grams of precision. Yes, this thing can hold around 2 kilograms of sample, and the minimum criteria is 60 grams. So that's the thing. Okay, so I think I have done uh, many thing. Oh yeah, one more thing is left. I should show you that also. So hi, Lucifer, hi from Germany, and John Doe says hi from Belgium. Hi everyone, and welcome to our stream. This is the OSIRIS Rex spacecraft. If you are just joining in, we'll be having the stream in just a moment, but before that we are just reviewing as in what will happen, everything. So let me now just tell you a little bit, just show you about that the tag only, how it will function. This thing has been developed by Lockheed Martin, as you know. So this is the video. This was simulated on Earth. The vacuum environment was created, but they can't simulate the gravity. Okay, but whatever simulation or whatever thing they simulated here, they said that if we have less gravity, the efficiency will only increase. So they just tested that mechanism here on Earth, and they were successful. And this is the video. So let me just play it. So this will how it will just go and touch the surface. Okay, and then it will blow the nitrogen air. I think now it is blowing the nitrogen, and the mechanism, as I have already shown, how it will just capture the thing now, and after that it will just take all the gravels and all the sands with it and store it. So as you can see here, right now it is being fallen down, but because of lesser gravity, I don't think so that will happen in on the asteroid. Okay, this is one more video which should be you should see. Yeah. Yes.
Solar system, an ancient remnant to the genesis of terrestrial.
Yes.
A one-of-a-kind spacecraft. An in-depth study.
Yeah,
OSIRIS-REx will capture a sample of Bennu's surface using a first-of-its-kind system called the TAGSAM.
Tag system, yes.
Invented by a Lockheed Martin engineer who conducted the first collection tests in his gravel driveway using a plastic cup and an air compressor. The TAGSAM acts as a reverse vacuum cleaner, blowing compressed gas to stir up material from Bennu and collecting it into a special ring-shaped canister. The spacecraft then stores the material in a rugged sample return capsule. Bennu is a fascinating asteroid because of its primitive carbon-rich organic compounds and water-bearing minerals. It's possible that OSIRIS-REx could retrieve organic molecules that may be similar to those that formed life on Earth. OSIRIS-REx, designed, built, and operated by Lockheed Martin.
Okay, so yeah, that's the thing. And if there is some other video, we just do this. Okay, so this we have already seen. Okay, yeah, that's what I wanted you all guys to see. Okay, so 51, Adnan says 51 minutes left. Yeah, that's the time, but we must be having the stream now. Let me just switch over to that. Yeah, we are having that. I'll just switch over. So guys, if you have any questions, you can just ask me, and if I can answer that, I'll surely do the right thing for you. So yeah, so hi Anthony Spinella, did it touch yet? No, it will touch it. We have 50 minutes right now, and we will be having the thing. So hi Uvid Dada. Sorry if I pronounced it wrongly, but yeah. So let me just throw you some facts about this asteroid. As you or as I already said, it has amino acids and it is a 3.4 billion years old, and it is an hazardous asteroid which can collide with the Earth. So it is very important to study this, and it also has water in it. That is also one more reason to study it, because this water is it is believed that
over 200 million miles away
asteroids. Okay.
OSIRIS-REx is preparing for NASA's most ambitious sample return since the Apollo program. After months of detailed analysis of Bennu's terrain, the team selected the Nightingale crater as the sample site for the mission. OSIRIS-REx will need to carefully dodge rocky hazards as it descends to a space no larger than a few parking spots. The
Yes.
spacecraft has mapped the terrain in high resolution, capturing a stunning catalog of images across Bennu's rough surface. And now, we are ready to target Site Nightingale for the touch-and-go sampling event.
In the dark voids of the solar system,
Manat Singh, it will actually have 3 attempts to do that.
Are the asteroids. There may be 1 million, perhaps 2 million of these cold, dark rocks. But these small worlds are anything but dull. In fact, some of them are time capsules from the very beginning of the solar system, unaltered for billions of years. And in fact, the clues to how everything around us began, from the formation of the planets to the beginning of life itself, may be locked up in these asteroids. And tonight, a spacecraft from Earth is going to touch one, bring back a sample, and prepare the long journey back to Earth where we can analyze it. Welcome, everyone. I'm Michelle Fowler from NASA's Goddard Space Flight Center, and thank you for joining us.
Cool
I'm speaking
mask.
to you live from the mission support area at the Lockheed Martin Space in Littleton, Colorado. As you can see, I'm struggling with my mask here a little bit. We're here to follow the sample collection for NASA's OSIRIS-REx mission. This is an operation referred to appropriately as TAG. Now, remember that this is a historic event. Today's endeavor will be the first time the space agency has ever touched the surface of an asteroid, collecting a sample of this pristine ancient material, a scientific treasure far more precious than gold. Joining me throughout the show will be the principal investigator of the OSIRIS-REx mission, Dante Loretta. Welcome, Dante.
Thank you, Michelle. It's really great to be here today. I'm a professor at the University of Arizona, and I have the honor and the privilege of leading this amazing mission for NASA and really for the world.
It's pretty amazing. So now the main event is happening in about an hour. And this is called TAG. Can you explain to us a bit why it's called TAG?
Yeah, today we're tagging an asteroid, and TAG is an acronym that describes our sample collection strategy. We're going to send the spacecraft down for a short duration contact with the asteroid surface, anywhere between 5 and maybe as long as 15 seconds. So we call it a touch and go, or tag an asteroid.
It actually is almost sort of like a quick touch, a tag. It's a very
It
great
will be
good way of putting
around
it.
Exactly.
10 seconds or 5 seconds
there's lots
of
of asteroids out there. We talked about the fact that there are a couple million. So why have we selected this particular one to sample?
Yeah, the target of our mission is called Asteroid BENNU. And when we were designing the mission, we had to consider both engineering constraints and, of course, our science objectives. And when we looked at the capabilities of our spacecraft, we knew we needed to go what was called a near-Earth asteroid. So we were basically looking at its orbital properties and its location within the solar system. We needed an object whose orbit was pretty similar to the Earth so that we could launch off of our planet, rendezvous and spend some time at the asteroid, and then leave and bring this precious scientific cargo back to Earth.
Absolutely.
And then from the science perspective, we're really answering some fundamental questions. Why are we here? Why is Earth a habitable planet? How did the origin of life occur? So we wanted an asteroid that we thought was rich in water, that may have brought the oceans to our planet, and also rich in carbon. We're looking for the organic seeds of life that may have led to evolution as we know it today.
And this is really an amazing point, our connection to these asteroids. So what you're saying is that some of the organic compounds in my body, some of the water in my body right now, may originally have come from asteroids.
Almost certainly. The Earth was accreted from these asteroids. Bennu is a remnant that survived that process, but it's the geologic history of our solar system that's locked inside this body.
Absolutely. Now, there are many other asteroids like Bennu in the solar system, and of course there are some that are even larger. Over the last decades, we believe we have found nearly all of the potentially dangerous ones. Oh, we'll pause.
OREX natural feature tracking system has resumed processing. Position uncertainty is 1.6 meters.
Excellent.
Okay. So that's a good
So
news.
getting back to my point, we know there are others out there that we have not yet detected. You know, in fact, just this past August, a truck-sized asteroid missed the Earth by less than 2,000 miles, and nobody even knew it was headed our way until it already passed us by. So for our survival, it's essential that we understand what's out there in our environment in space. And this is one of the main objectives of the OSIRIS-REx mission. We'd like to go out and meet Bennu before something like Bennu comes and meets all of us. So Dante, what can you tell us about this idea of planetary defense?
So as a result of Bennu having this optimal orbit for sample return, it also is what we call a potentially hazardous asteroid. Because its orbit literally does cross the orbit of the Earth, and there's a probability about 150 years in the future that Bennu may in fact impact our planet, creating a natural disaster. So OSIRIS-REx is really trying to study Bennu's orbit very precisely. We know that sunlight actually influences the trajectory of these small asteroids, and we're studying that phenomena, how it interacts with the asteroid surface, and ultimately how it's going to allow us to assess the impact risk that Bennu poses to the Earth.
Absolutely. So the idea of planetary defense isn't just an intellectual exercise. It's something that NASA takes very seriously. A little later in the broadcast, we're going to talk with some people more about protecting the planet from surprise visitors from space.
Just a sec, guys.
We have a lot of exciting stuff to share with you about this TAG operation, from how it works to why this overall mission matters so much. And you can be part of this too by joining us on our social media platforms. I'd like to introduce James Traley at our social media desk.
Really sorry for that
Thanks, Michelle. My name is James Traley, and I'm a producer at NASA Goddard Space Flight Center. And today, I'm joining you on social media to share the excitement of the OSIRIS-REx mission and this incredible sample collection event at Asteroid BENNU. To join us today, you can use the hashtag #BennuAndBack on Instagram, Facebook, and Twitter to join the conversation and share the excitement with all of us here. You can also follow the mission's Twitter account at OSIRIS-REx for live updates as we make our TAG attempt. We actually have a poll going on at this Twitter right now, where we're asking you, how much sample do you think OSIRIS-REx will pick up at Bennu today? I'll check back in with you in a little bit. It should be more than 60 grams, that I know. Back to you, Michelle.
Thanks, James. Okay, so right behind me is the MSA, the Mission Support Area for OSIRIS-REx. And today it is filled with very excited people, the scientists, engineers, and technical specialists who've worked on this mission, in some cases, for more than a decade. So back there is Gary Napier from Lockheed Martin. He's right in the middle of it all. So Gary, what's the feeling in the room?
Michelle, like you said, I am just right behind you, about 20 feet. We're here in the larger Lockheed Martin Mission Support Area, where we're operating 6 of NASA's spacecraft around the solar system, 4 of them at Mars, 1 of them at Jupiter, and this one right here, OSIRIS-REx. We're going to take you into the operations center here at OSIRIS-REx. This is where the flight team is right now. The controllers are already on board. We've heard some good call-outs right now. And in a little while, we're going to come in here and talk to some of them and see how things are going.
Yeah, he needs to talk
right now. Back to you, Michelle.
He needs to talk very late.
So I think right now we have to acknowledge something, that this is a bit of an unusual broadcast. We're dealing with some pretty big challenges tonight because we're doing this all in the midst of a pandemic. So you'll notice that I'm wearing a mask. I've certainly never hosted an event wearing a mask before. Forgive me if I struggle with it a little bit tonight, and make sure that it's in the right position. And when we interview people, you'll notice that we'll be standing farther away than normal. And also, I'm going to stay right here. Normally I might be back in the mission support area, but I'm not allowed to go back there. I'm isolated from them. So it's amazing that with the incredible operation going on at Bennu tonight, and the people all around me who've been working on this for years to make this a success, we still have to deal with the challenges of COVID-19. And so, tonight our attention is going to be on this wonderful event, actually sampling an asteroid. And, that's incredibly adventurous. It's very happy, but we're going to remember to actually take care of each other. We can't forget that. So please bear with us today as we are working with our masks and trying to do this the best way we can. Okay, so Dante, give us a chance now. Give us sort of an idea about how the engineers back there are actually flying.
If you like the stream, just
so
like this.
It's important to understand that the spacecraft is actually literally on the other side of the solar system, over 200 million miles away from the Earth. So any signal that we were to transmit here would take over 18.5 minutes to reach the spacecraft. So when we get these signals back, we're actually seeing things that happened in the past at the asteroid. As a result, we have to have a very smart spacecraft. It has to make its own guidance calculations and make its own decisions. And in fact, instead of getting high data back, we're only getting a very low data rate, what we call breadcrumbs, just key pieces of information from the spacecraft that tell us when key events have taken place in the TAG sequence.
OREX has processed its next image. Position uncertainty is 0.9 meters.
Okay.
So that's an example of the kind of information that we're getting back from the spacecraft. It's got its onboard natural feature tracking system, which we're going to hear a lot more about today.
Absolutely. Yeah.
And guys, let me tell you,
I guess after
very
that,
interesting
we
thing.
are dealing with, actually the TAG event itself. But I understand that we're not going to be able to see images tonight in real time. That we have to wait a while. Why is that?
The images take a lot of data to bring back to the bring back from the spacecraft to the Earth. And since we're on that low data rate, what we're using today is this real-time simulation that we've put together. So what we're seeing here, and we'll be referring to this throughout the broadcast tonight, This isn't any kind of real information from outer space. This is what we expect the spacecraft to be doing. So it'll let us know when key events are programmed to take place on the spacecraft and to be received back on Earth. There may be some lags in communication, but this is going to really help us visualize what's actually happening at Asteroid BENNU.
Okay.
So when will we expect those first images?
So everything's going to play out at this very low data rate through most of the broadcast today, and then the spacecraft has to back away from the asteroid surface, it has to cool off, it has to get back on its solar arrays, and then it's going to turn that high-gain antenna to the Earth this evening, and we expect images to be coming in overnight, and we hope to have some great information for everybody.
And this was the rehearsal
I'm
which
really
it
looking
did.
forward to those images. People around the world are. So at this point, the spacecraft has left its home orbit. And it's on
It
its way to
actually
the
did
sample
2
site.
rehearsal before performing the actual mission, so that was the imagery of that. It just went down and came up back without touching the surface.
Days ago, we actually hosted a Reddit AMA with a few of our scientists and got a lot of fantastic questions. We wanted to recap a couple of them for you right now. So our first question asks, how is it possible to map such a tiny speckle in the sky? Do you have any detailed images that you can share? Do
Yeah,
you
we
really see
have.
the landing site, or is it all based on measurements of some weird properties and calculations? So, yes, our first observation of Bennu actually came from right here on Earth.
And
from
it
the
was
Arecibo
supposed to be
Observatory in Puerto
very
Rico.
smooth
This
asteroid.
huge radio telescope gave
And
us a
that's
basic
where the
understanding of the rough shape
interesting
of
thing.
Bennu, this kind of strange top-like shape that you see right here. As OSIRIS-REx was actually out in space and began making its approach closer and closer to the asteroid, it used its suite of onboard camera instruments to actually image the surface in increasing detail. Bennu grew in detail from just a few tiny pixels on our screen to this super high-resolution world that you see right here, littered with giant, rugged boulders. Another question from Reddit is asking us...
Hi, Origami Masters.
So, would it have been feasible to have a robotic arm pick up a rock? Would a single rock have been better than 100 tiny grains of sand or ice? So, the team had originally designed OSIRIS-REx to sample on a nice, flat, sandy-like surface. But as you just saw, Bennu is not at all like that. It's super rugged and filled with giant boulders. So the team had to work with what we had designed for, which was that flat, sandy surface. If we were to try to sample on a rock, that actually presents a number of challenges of its own. For example, if we were to pick up a rock, it might actually just crumble away, and we wouldn't actually get a sample out of it. Also, some of these rocks might actually be a bit too stuck to the surface. And if we were to try to pry those loose, they might not actually budge, and we wouldn't actually even get a sample. So, these are all things that the team has to consider when designing something that's going to be operating millions upon millions of miles away from us here on Earth. So for now, back to you, Michelle.
So this mission was designed to have, guys, means this Bennu was supposed to be very soft and plain and sandy, and this was designed because of that only, keeping in mind that only. And the NFT, the natural feature tracking feature which it has, it is basically used as a secondary device. If the LiDAR, which it basically will be the hardware, the LiDAR, if it fails, then it will use the natural feature tracking. But because of the boulders, the natural feature tracking system or the software became the primary concern, or you can say the primary instrument or the software which they will be using for the touchdown. So that's the thing. So thank you so much. And if you are liking the stream, just give it a thumbs up and enjoy it.
OSIRIS-REx spacecraft is preparing for an ambitious sample collection attempt at Asteroid BENNU. Before it makes its approach to the rocky surface, let's take a look back at some of the incredible firsts for this mission, which almost seem like something out of a Hollywood movie. This is the first asteroid sample return mission for NASA, and it could be the largest return from space since the Apollo astronauts brought moon samples back to Earth. While getting set to grab a sample, OSIRIS-REx has set not one, but 2 Guinness World Records. Its first for the smallest
Thanks
ever
for subscribing.
body orbited, and its second for the closest orbit of a spacecraft. This tight orbit has brought the spacecraft so close to Bennu that OSIRIS-REx's onboard cameras and laser altimeter have been able to image and characterize the asteroid's surface and shape better than Earth, our own moon, or any other celestial body.
Yes, it has the most detailed.
OSIRIS-REx has imaged Bennu down to 5 cm per pixel resolution, providing us with an unprecedented view into this rocky and boulder-filled world. With 28 onboard thrusters, OSIRIS-REx is one of the most maneuverable spacecrafts. This allows it to carefully and precisely descend to a spot on Bennu that is no larger than a few parking spaces.
Thanks for
There have certainly
subscribing,
been some
Sheldon.
unexpected twists along the way. However, OSIRIS-REx has capitalized on these moments. Right after arriving at the asteroid, OSIRIS-REx imaged rocky ejecta that has been bursting off Bennu. This is the
was a
first time we have
epic
been able to
discovery.
observe the entire life cycle of a natural satellite ejecting off an object, entering into orbit, and returning back to the surface. Because of Bennu's extremely rocky surface, the team needed to adapt the spacecraft's navigation method to an optical approach known as natural feature tracking, or NFT. This is the first time this approach has been used in space, and it will allow OSIRIS-REx to steer itself down to collect a sample from Bennu. And now, OSIRIS-REx is looking to set another first for NASA.
Thanks, Teddy,
Successfully
for
collect a sample of
subscribing.
an asteroid and deliver it to Earth by 2023.
Sarah, and yeah, this will be delivered like this, the parachutes and all, yeah.
Welcome back. If you're just joining us, I'm Michelle Fowler from NASA's Goddard Space Flight Center, and with me is Dante Loretta from the University of Arizona. And you are here with us on a historic evening. It will be NASA's first sample return from an asteroid, the attempt to actually sample the asteroid Bennu. The spacecraft OSIRIS-REx is descending toward Bennu right now to take a sample and return it back to
Yes.
Earth. So Dante, let's talk more about this real-time simulation that we're looking at.
Yeah, it's been an exciting day already, Michelle. We're well over 3 hours into the TAG sequence, which is the pre-programmed set of commands that are already on the spacecraft. Earlier, we departed our orbit around the asteroid, so we're flying over the sunlit side of the asteroid, taking images for the onboard guidance system called natural feature tracking. A couple other key events that have taken place already is the spacecraft has deployed its robotic TAGSAM sampling arm, so the
Okay.
arm is ready, in position to collect that sample. And we've turned on and started collecting science data from one of our science instruments, the OTIS thermal emission spectrometer. The spacecraft has already moved into its second natural feature tracking attitude and is getting onboard positional updates as we speak. And I can tell you, everything is going exactly according to plan right now. It looks really
Wow.
Oh, it's been an exciting day. So OSIRIS-REx has traveled more than 2.5 years as it navigated its way
Jania.
to this delicate orbit around Bennu. And once there, it began mapping the surface, one of the many tasks it and the engineering team have been conducting since it arrived. And there have been some challenges and surprises too, correct?
Absolutely. I can tell you already the science return from OSIRIS-REx has been phenomenal and rewritten a lot of things about what we know about asteroids. I'm going to talk really about 3 of some of the most interesting results for me. First off, we learned literally about 1 week after getting into orbit that Bennu is what we call an active asteroid. It is ejecting particles from its surface. These particles are coming off at relatively low velocities for the most part. They're actually going into orbit, spiraling around the asteroid, providing some excellent science, allowing us to map out the gravity field of this small body at an unprecedented detail, way beyond what we expected to do. The other thing
Okay,
that
so
we
there's
saw
an
right
update
away
with
as
the
we were
timing.
approaching is that there was some generally dark black surface as expected, but there were these really bright boulders that were shining like beacons to us. And as we trained our science instruments on there and characterized their mineralogy, we were actually able to link them to another asteroid called Vesta, one of the largest asteroids in the solar system, and actually the target of NASA's Dawn spacecraft, which did a phenomenal job characterizing this target. And this just shows you that these asteroids are exchanging pieces back and forth as they collide into each other and shoot their particles off into space.
OREX has processed its next image. Position uncertainty is 0.6 meters.
Wow.
Wow. It is now basically
And I would say,
Closing
back to the
its-
science, the final result
Yeah.
that really is important from this mission is we did expect this asteroid to look sandy and beach-like. And that was based on the thermal properties as determined from telescopic observations from Earth. And we got there, and we used the OTIS and our OVIR spectrometer to map and produce a thermal inertia characterization of the entire surface. And everything turned itself upside down based on our models. The areas that we thought would be beach-like based on thermal properties turned out to be the largest boulders on the asteroid's surface. And the more fine-grained regions turned out to have what we call this higher thermal inertia, completely opposite of everything we expected, propagating a lot of great science as a result.
And so when you mentioned that there are these bright rocks from Vesta, does that means that Bennu was once in the asteroid belt between Mars and Jupiter?
That's right. Bennu is currently a near-Earth asteroid, but it's a recent wanderer into the inner solar system. We actually think it's fragments of a much larger asteroid that was catastrophically disrupted maybe 1 billion years ago.
Wow, that is so cool. Thank you so much. Okay, now as challenging as it is actually getting to Bennu, capturing a sample of the asteroid is something else entirely. And the team needed to develop this remarkable system. The OSIRIS-REx mission has been in development for almost 20 years, with the engineers and
Yes,
scientists developing new
exactly.
technologies and strategies to accomplish something that's honestly never been done before.
And
This is
before-
particularly challenging because Bennu has such a weak gravity field. So when you think about going into an orbit around something, how do you orbit something where the gravity can't grab you and actually push you into orbit? It's all about flying the spacecraft.
It is 98
It's also very
micro-Gs.
difficult to take a sample
Gravity
in a
of the
very
Bennu.
low gravity environment. So
98
thankfully, we have the
micro-Gs.
mastermind behind the device that's going to take the sample tonight, Lockheed Martin's Bo Bierhaus.
Which is
Welcome,
1
Bo.
millionth
Thank you,
time
Michelle.
of
It's great to be here.
our
Okay, so
gravity.
let's talk a bit about why working in this low gravity environment makes it tough to get a sample, because you might think sort of at first you could just take like a robotic claw or a robotic arm and scoop something up, but that's not going to work in these conditions.
That's exactly right. The microgravity of Bennu provides a challenge of sampling that we don't normally face on Earth. You can imagine trying to use a shovel or a scoop on Earth, and the ground pushes against you, but the gravity keeps you on the ground. On Bennu, the surface gravity is thousands of times lower than on Earth.
Million.
So if you pushed a shovel or a scoop into the ground, you'd push yourself right off the surface. So we had to come up with a technique that worked within this very low gravity. We also had the challenge of uncertainty of the mechanical properties of the surface. And both of those things made landing a challenge. We wouldn't know how to grapple particularly well in this material. So we had to come up with a technique that worked in the microgravity environment and that could work in this TAG architecture, this touch-and-go architecture of just a few seconds long.
Now, I understand you have brought some models with you, both of the spacecraft and of the instrument that will be taking the samples. So show us what you've got here.
That's exactly right. So this is a scale model of the spacecraft. The arm
Hi,
is extended in
everyone.
the sampling position. Partway down the arm, you can see 3 gas bottles. We'll use one of them today. This has high pressure nitrogen gas, which passes down the arm into the TAGSAM head itself. And here I have actually a full-scale TAGSAM. It's actually a device that we used for collection testing on Earth. The gas comes down. I don't have the tubing here to show you, but the gas comes down to the center of the TAGSAM, is split into 2, and passes underneath the head. There is now a high-pressure bubble of gas underneath the head that is mobilizing material, much like wind blows dirt on a dusty day on the Earth. And we're surrounded by the vacuum of space. So the gas there's a high-pressure gas underneath TAGSAM, and it will escape into the low-pressure environment of the vacuum of space surrounding it. And it does so through this screen around the entire perimeter of the TAGSAM head itself. But while the gas can escape, the screen traps the material safely inside.
It's
Wow.
one of these sort of brilliant things about engineering for space is to have things that are really, really rigorously built and they can't break easily. And so there aren't even any moving parts here, and you're using the vacuum of space itself to provide the pressure to collect the sample.
That's exactly right. When we were first designing this device many years ago, we were thinking we wanted to keep it as simple and as robust and as foolproof as possible. We didn't want any mechanisms. We didn't want any electrical devices. The entire collection is driven by the dynamics of the gas itself. So once the gas is released from the bottle and travels down the arm, the gas does all the work.
That's so cool. So what size particles are we talking about collecting here?
Well, TAGSAM is designed to collect 2-centimeter particles, and I have some examples here to show you. So this is a 2-centimeter sphere. It's about the same diameter as a nickel. But of course, most geologic materials aren't actually perfect spheres. Most geologic materials are irregularly shaped.
OREX has processed its next image. Position uncertainty is 0.5 meters.
It is
That is
coming
fantastic.
down. That
Excellent.
is so good.
So we're going where we need to go to get this material. So most geologic material is irregularly shaped. So this rock is actually about 4 centimeters long in its longest dimension, but we were still able to collect this in a test on Earth. And that's because even though it's 4 centimeters in this dimension, you can see that it's much less than 2 centimeters in that dimension, or even 2 centimeters in the other dimension. So while we're limited in one direction for 2 centimeters, as long as the other 2 directions are less, we can actually collect much larger particles into the TAGSAM head itself.
Well, excellent. So I understand we have some animations queued up to give us a sense of what's going to happen on the asteroid tonight.
Sure thing. So what you're seeing is the spacecraft descending at a leisurely 10 centimeters per second to the surface, 15 times slower than
Thanks,
walking
Twitter, for
speed.
subscribing.
It contacts, the spacecraft senses contact and fires the gas. The gas mobilizes material underneath the TAGSAM head. That gas escapes into the vacuum of space through the perimeter, and materials collected inside the TAGSAM head.
Then
the
finally
spacecraft
it
fires
leaves
its
the...
thrusters and backs safely away from the surface of the asteroid.
Exactly.
Well, thank you for the tutorial, Bo. I mean, clearly the science community is going to be very excited to study whatever TAGSAM collects. So thank you so much.
Thank you. It's wonderful to be here.
And
okay, well, speaking of all the important the thing that's happening in less than an
interesting
hour,
fact, guys, 75% will be preserved for future research.
In Colorado. Right behind me is the Mission Support Area, or MSA, and that's where OSIRIS-REx team members are keeping an eye on the spacecraft.
Thanks, Leonardo, for subscribing.
So let's send it over to Gary. What's going on, Gary?
So as I showed you earlier, we're just around the corner from you. This is the heart
Thanks
of the
for
TAG operation.
subscribing.
We thought this would actually be a really good
Oh,
time
my
to kind of check in with the team, see how things are going, and the best person to do that is joining me, and this is Sandy Friend. She's the OSIRIS-REx Operations Manager here at Lockheed Martin. So, Sandy, thanks for joining us. How's the team doing?
Oh, the team is great. We've been here on console since 6 o'clock this morning, setting the final commands, getting ready for TAG.
Really cool. I know there's like 40 people on your overall flight team, but it seems like there's about 20 of them here.
Guys, actually,
right
this thing is very sensitive, so they need to really monitor each and everything because the gravity is in micro G. So any force here and there, then mission can just go fully wrong. So they need to be very, very precise in everything. That's what they're doing.
Even from home. So let's talk about a couple of the positions we have in the room. In the back corner over there is Dale Howe. Dale is our TAG phase lead. You've been hearing his voice calling out events as they complete on board the spacecraft.
Hey.
Here in the center area, we have Curtis Miller. Curtis is our NFT lead. He is watching natural feature tracking, and that is how we are navigating to the surface of Bennu today. So he is watching how NFT is performing, how many features we're matching, and how that system is working.
So I know natural feature tracking, like you're saying, is kind of
subscribing.
keeping an eye on telling us where we're going. And I know we're going to get into that a little bit later in the show. But also it's important just to stay in communications with the spacecraft. So what about comms?
Yeah, absolutely. So right behind me here is Sierra Gonzalez. She's our real-time operator, or our ACE. She is working with our Deep Space Network partners. Currently we're on a station in Goldstone and in Canberra, making sure we maintain our comm link. And our comm link is only 40 bits per second, so we're just bringing down that key information, but Sierra's here to make sure we keep that link going and our station operators informed. And right next to her is Estelle Church, and Estelle is our systems coordinator for this event. She's built all the command products that are executing. She's keeping an eye on how everything is progressing on board the spacecraft, talking to all of our subsystems here in the room, and making sure things are going just as planned.
Very good.
Hey.
I know you yourself have actually been on this project for quite a while, even back to the development. I mean, how are you feeling tonight?
No, actually, I'm excited. I feel like we've done everything we can to make this successful, and I've been on this mission for 7 years, so I've watched it go from a spacecraft on paper to being built in our high bay to launch and everything here. And yeah, I'm excited. My kids were excited this morning, and we are ready.
Right
Wow.
on. That's so fantastic. So we're going to let you guys get back to it. I know we don't want to interrupt too much. Sandy, thank you
there
so
was
much
some
for
connection
joining
issue.
us. And I know that folks around the world are paying attention to this right now. We're seeing a ton of social media coming in. So let's go over to James on the social media desk and see what some of those conversations are about.
Yeah, thanks, Gary. It's awesome to see the team over there in the MSA. You can really feel the energy in the room, especially after every call out from Dale. And right on cue.
OSIRIS is slewing to the TAG attitude, the third and final natural feature tracking attitude.
All right, so we're inching ever so closer down to the surface of Bennu. But today we also want to hear from you. So you can check in on live updates at our Twitter account at OSIRISREx, or using that hashtag to Bennu and back across social media to get in on the conversation. In the meantime, a question I had when I first started covering the mission
we have
is,
around
how do you even begin to prepare for a
43
mission of this
minutes.
scale? I mean, when I first heard about OSIRIS-REx, it really seemed like something out of a big budget movie. But this is a reality. We're actually going to be trying to sample on an asteroid. To put things into perspective for you, Bennu is about the size of the Empire State Building. That's really small for an object and makes it exceptionally challenging for us to orbit something with such a weak gravity field. And that sample site we're going for today, Nightingale, it's just a few meters in width, which is about the size of a few parking spaces. So just take a step back for a second and put yourself in the shoes of some of those engineers on this mission. And imagine trying to park a spacecraft on an asteroid 200 million miles away in a space no larger than a few parking spots. As if parallel parking on an asteroid isn't hard enough, imagine also trying to dodge hazards like rocky boulders and all kinds of things as you're making your descent down to collect a sample. And on top of that, the team has actually programmed the spacecraft to steer itself down to the surface. It's truly incredible, this mission, and all the foresight that went into it. It really blows my mind. We actually have a couple questions coming in from Twitter, and a lot of people are actually asking about our fuel usage for the mission. This one question is asking, how does the craft have enough fuel to return back to Earth from the asteroid? So we're looking to bring that sample back in 2023. And OSIRIS-REx's thrusters are actually powered by hydrazine, which is stored in a container on the spacecraft. We're tapping into a little bit of that fuel today, on the order of maybe tens of grams, not a lot. Because, as you remember, Bennu has this microgravity environment, and it just requires a little bit of thrust to kick us in the right direction and collect the sample. That return trip back to Earth, that's a bit of a different story. We're going to be using a lot more fuel for that. But don't worry, the team has thought way ahead and has packed more than enough fuel to get us back here safely in 2023. But there's a lot more to come, and I'll check back in with you in just a minute. Back to you, Michelle.
Thank you, James. Okay, so let's take a quick look at the simulation to see where we are. As you notice with the simulation, the spacecraft has its arm extended now and is on a slow path toward the surface. So as we get closer to the moment of contact, the drama starts to happen in slow motion. And this is to maximize precision and minimize unintentional surprises. So, speaking of surprises, there is one big aspect of the OSIRIS-REx mission that's all about preparing for the unexpected. And joining us to discuss this is NASA Planetary Science Division Director, Lori Glaze. Now, Lori, you have kind of a dramatic specialty and a responsibility that comes with your position at NASA. You actually worry about things like planetary protection.
Yes. Planetary protection or planetary defense is sometimes what we call it, defending our planet from potential impacts. And Bennu is in a special class, and I think Dante spoke about this a little earlier, that Bennu is actually a near-Earth object, or a NEO. And a NEO, or near-Earth object, is an asteroid or a comet that orbits the sun, much like our planets do, but they're slightly unusual.
OSIRIS has reached the third and final natural feature tracking attitude. The spacecraft will hold this fixed attitude until TAG.
Excellent.
Wow, yes.
Great news.
Yes.
So back to NEOs.
Yes.
So NEOs are somewhat unusual.
So guys, if you like the work what I do in this channel, basically you will find every launch that happens in the space industry, mainly space events and space related videos and rocket science. So if you are that type of guy, so you can just subscribe and support me on Patreon, because it really helps me perform this channel and keep this channel alive. Thank you so much.
That could actually do damage to the Earth's surface if they were to impact. They can pass by Earth closer than the moon about once per month. And that's why it's really important for us to find them as early as possible so we can track their orbits, study their characteristics, and if necessary, we can mitigate a potential future impact threat. And that's where a mission that we're building now called the Double Asteroid Redirection Test, that's where DART comes in. And DART is going to launch in
this
next
is a
summer,
very exciting
2021,
also.
and
I'm really excited about
something we call the kinetic impactor technique. That could be used one day to help us mitigate a future potential impact threat by bumping an asteroid ever so slightly that's on a collision course with our planet into a slightly different orbit so it misses Earth.
Just a little bit is all you need.
Just a tiny
one. Yes, we don't need much
force. That's really exciting. Now, I also understand that not all of the asteroids in the solar system are the same. There are different sorts, and NASA has some upcoming missions to study these different kinds of asteroids. So tell us a bit more about that, please.
Absolutely. Yeah, we know that the majority of our asteroids are found in the main asteroid belt between Mars and Jupiter. And in fact, we have a mission that's going to launch in 2022. It's called Psyche. It's going to visit one of the biggest asteroids in the asteroid belt that's actually called 16 Psyche.
Wow.
And this mission is going to arrive in early 2026 and help us better understand if this asteroid is potentially actually the core of a planet-sized object. We also have other types of asteroids called Trojans that are clustered in two groups that lead and trail in Jupiter's orbit due to a balancing act of the pull of both Jupiter's and the Sun's gravity on them. NASA has a mission to those Trojan asteroids called Lucy. It's going to launch next fall, about a year from now. And it's going to
Wow,
go visit several of these Trojan asteroids.
there are so
We have
many
a new
missions.
mission called Janus, and we selected this mission through our Simplex small mission program line. This mission is going to send actually 2 small spacecraft, very small spacecraft, to 2 binary asteroid systems and help us
Wow.
understand what it is that makes these binary asteroid systems different from one another. And so studying this full breadth of these diverse small worlds will continue to help us fill
I
up the
just
knowledge
love
gaps
science,
of how our solar
space,
system actually formed and
and
evolved over time.
Space
But it
agencies.
seems with all these missions coming up, we're sort of in a golden age of asteroid exploration. But then there's this other aspect of the OSIRIS-REx mission, which is the sample return. And it turns out that we're also beginning this golden age of sample return to it, and not just to asteroids.
You're absolutely right. And we're really excited about all of these samples because they're so precious
And
and there's
we
so
are
much
heading
science we
for
can
the,
do with them. In addition to OSIRIS-REx, we're also partnering with the Japanese Space Agency on their mission called Hayabusa 2, which is actually already on its way back bringing a
yes.
sample from Ryugu. They're going to
Ryugu.
be coming back to Earth in December. We're also
Hi, everyone.
partnering with Japanese Space Agency on another mission of theirs that's going to return a sample from Phobos, which is one of the 2 moons of Mars.
Nice.
And then finally, at the end of this decade, we're going to send a mission to Mars to retrieve the samples that are collected by the Perseverance rover,
yeah.
which is really truly our first astrobiology mission from NASA. And it's focused on looking for finding potential life, ancient life on Mars. So sample of return is really important because it allows us to study these pristine samples back here on Earth. We can then take advantage of our room-sized laboratories. All of this.
OREX ops. OREX has begun moving the solar arrays to the Y-wing configuration to avoid possible contact with the surface during TAG.
Great news. Moving right along. So when we bring the samples back, this allows
we
us to
started
use
the
all of the
history that all the
laboratory
young ones will
capabilities
get
that
to
we
hear
have
and
here on Earth.
hopefully
We can use
see
the
them.
full suite of the scientific instruments that we have at our disposal to help us better
you will also
understand the
get it, no
sample,
worries.
the
It's just a
compositions, and the
decade
history of the
from
body
now.
from which they came. And also having the samples back here on Earth allows us to preserve them for future generations to come and allows their future explorers to analyze the samples
With
using
better
techniques,
technologies
instruments
and-
that haven't been invented, and
Yeah.
to ask questions that we don't even know to ask yet.
That 75% will be preserved
Your
for
life is all
future
about how we navigate
research.
unknowns. This is something that's happening in real
It's
time
so cool.
around us tonight. So it's reassuring to know that there's an organized plan that you're in charge of to help take some of the uncertainties out of at least one dramatic category. so Lori Glaze, thank you for joining us this evening. So good to see you.
Thank you so much for having me. I just want to add that it's been fantastic to watch the OSIRIS-REx mission so far, and I'm really, really excited for what's ahead tonight, and I want to say congratulations to the entire team.
Thank you so much.
Thank you.
Now, asteroids are not easily navigated. They're hard to see, they have low gravity fields, they're dark and rocky, and traveling around the solar system where everything is moving rarely means traveling
NASA actually made the longitude-latitude system which we have here on Earth to basically map the asteroid and navigate the asteroid.
Bennu from a distance, and it started to fill up the camera field of view. It looked exactly like we thought it would, with a few boulders sticking out. But as we got closer, we expected to see a very sandy surface with maybe a few boulders here and there. And what we saw is very little sand. And we saw these mountains, we saw boulders, we saw rocks, and we saw very few areas that had this sandy surface that we were expecting and what we had designed to.
And because of that only,
we have never done this before. We're actually going to collect a sample and bring it back down to Earth for further examination by scientists.
In order to
this is the
achieve that
cartridge
objective, the OSIRIS-REx spacecraft has
they
been
will put in.
navigating around Bennu for about the last 2 years, studying it in great detail, and also overcoming a number of challenges that Bennu has presented. We were looking for locations on Bennu that were 50 meters in diameter, relatively flat, and covered with fine-grained
then they
material. And by
selected 4
fine-grained material, I mean stuff that's the
sites for
size of
landing.
a dime or smaller. We realized that there were no sites on Bennu that even came close to meeting this criteria. Everywhere we looked was too small and covered with boulders. So we actually had to fly a number of additional closed passes over the asteroid and rethink our entire plan for grabbing the sample.
Exactly. But how can
After
you grab
the additional observations of Bennu, we had to down select to 4 sites and then go back and survey those sites even further to select the final primary sample site.
My first impression of Nightingale is that's the last place I wanted to go. But as we started looking at other sites, We saw that one, this is probably one of the most sampleable sites, and two, we were overperforming in our navigation capability and our ability to contact. Natural feature tracking works a lot like the human mind in that we pick up landmarks along the way. As we descend, we look at features on the ground. We program the computer to recognize certain features. It takes a picture, says this feature is not where I expected it to be, it's a little bit off to the side, updates its position based on where it's pointed and where that feature shows up in the camera position.
Yeah, this is the
The
rehearsal
tag
which they
event
did.
is our touch and go event, which is where we'll actually be retrieving the sample from Asteroid BENNU. We start with a series of maneuvers, one of them being the checkpoint burn, which is where we'll actually check our position and velocity in relation to the sample site.
And then the match point burn, about 10 minutes later, we'll zero out our horizontal velocity relative to the surface. And then about 10 minutes after that, we make contact with the TAGSAM, fire the gas bottle, and then back away.
And we hope to
This
get
is
at
getting
least
close,
60
guys.
grams of sample, and then we'll be able to store that and bring it back down to Earth.
But there are several things that could go wrong, and we also have to be prepared that we won't be successful on our first try at Nightingale.
We don't only get one shot at tag. We actually have 3 nitrogen bottles on board the spacecraft, so we can potentially do 3 tag attempts if needed. We go through several what-if scenarios, and this is how we actually prepare for a lot of our contingencies.
So we've had to look all around the surface and identify the rocks and boulders that
It
if the
should not
spacecraft were to
happen.
tip over up to 25 degrees, it could come into contact and be damaged.
We had to develop a hazard map, which we program into the computer and says, if you're getting too close to those hazards, we'll do a wave off, we'll back away from the asteroid, and we'll come back and do this another day.
Everything might work perfectly. We come down, we touch the surface just where we want to, we fire the gas bottle, but the area we contact is covered in large rocks.
And then we
Those rocks
don't
would
get the
prevent
sample.
any fine grain material
Yeah.
from being stirred up and captured in the
There are so
TAGSAM
many
head.
challenges.
Another similar scenario is if the TAGSAM were to touch on the edge of a boulder and become tipped up. In that case, when the gas bottle fires, much of that gas escapes out the side, not churning up the material that we want to capture. The day of tag is going to be really exciting, but the excitement for our team doesn't end there.
We have to verify that we have a proper sample.
First, we're going to image the TAGSAM head by sticking it in front of one of the cameras. Then we're going to do a maneuver called the sample mass measurement, in
This
which
is
we
what-
stick out the arm and we spin
meant
the
of
spacecraft
inertia.
in order for us to decide if we've collected enough mass to be able to stow the sample and return home, or if we have to try again.
This is the culmination of a lot of work. It's probably one of the most exciting missions that I've worked on.
It is really exciting to know that we're finally going to be able to
I'm
touch
also
the
really very
surface of the
excited.
asteroid and collect the sample.
We
to
are
return
living in
back
this
to Earth.
time, guys, where
So
these
step
things
back for a
happen.
moment and realize that tonight's events are exceedingly rare and historic. Humanity has only landed on a few different bodies in the solar system, and actually retrieving a sample is even more rare. So luckily with me tonight are some of the people that know better than anybody all the challenges that it took to get here. So let me introduce Mike Moreau. Mike is the OSIRIS-REx Deputy Project Manager at the Goddard Space Flight Center, and Coralie Adam is TAG Navigation Manager at Kinetics Aerospace. So welcome, Mike and Coralie. How you guys doing?
So excited.
So excited we're less than a half hour from tag now.
Yeah, you can feel the energy all building. So I should mention at this point that it's possible, you've been hearing this before, cheers from the MSA. So can you give us a sense what's going on right now?
Yeah, so every few minutes, a navigation camera image is taken by the spacecraft of the surface below, and it's sent to the natural feature tracking system. And that system identifies features in the image and sends a signal back to Earth that it was successful.
Position uncertainty is 0.5 meters.
Okay.
And the team celebrates.
So
it tells us we're on track to our next target.
it is basically
Absolutely. So
sticking
now,
to that.
clearly there's a lot to talk about in terms of the mission, but once again, you had to do all of this in the midst of this COVID-19 pandemic. So were there any mission expectations that changed? How did you deal with that?
Yeah, for sure. I mean, as the whole world was coming to grips with the pandemic in the March timeframe, this team was in the midst of preparing for our first tag rehearsal, the checkpoint rehearsal that would
It's
take the
28
spacecraft
minutes,
only 65
William.
meters above the surface. So we had to rethink the entire way in which we were going to do that rehearsal with only a skeleton crew
countdown
here
is
in the
there
building
on the screen.
and with many of our team members remote, as Sandy mentioned before. Today we have people literally all over the building monitoring, also at Goddard Space Flight Center and at the University of Arizona watching this event today. But thankfully we got through checkpoint rehearsal in April and match point rehearsal in August.
And all those special considerations, they're still going on around us today, right?
Yeah, I mean, you could see people spaced out in the MSA when you were over there, and you know, we had more time to prepare for tag in order to accommodate that and get everyone into the building here today. So I'm just incredibly proud of our team for their efforts to keep the project on track for TAG in spite of all of these challenges.
Yeah.
Absolutely. So I know NASA's famous for having to deal with unexpected situations, and this COVID-19 thing is kind of a different flavor of unexpected situations. So we're going to deal about that. Okay. So now let's talk more about the challenges of TAG that we introduced in the video segment. So Corley.
Right, so you've seen that Nightingale site is an extremely challenging spot to navigate into. There's boulders all around it. This is totally different than how we originally designed the system to target a 50-meter diameter area.
Exactly, they need
Nightingale's 10 times smaller than that.
10 times
so
smaller,
it required
yeah.
the whole team to rethink how to safely navigate into the contact with the surface, and we had to come up with some new ideas.
Yeah, so the original navigation approach used LiDAR, or laser-based navigation, to take us to the Nightingale crater. But when we saw what Bennu looked like, we realized we had to switch to a vision-based approach, and that's the NFT system that you've been hearing about.
Yeah, so the Kinetics navigation team has spent the last 2 years learning how to navigate around Bennu using optical navigation techniques very similar to what NFT is doing on board the spacecraft today. So Kinetics worked with scientists and the Lockheed Martin NFT team to map the surface of Bennu.
OREX has processed its next image. Position uncertainty is 0.5 meters.
That's really good.
Really honing in. So we mapped the surface of Bennu to unprecedented resolution of 2 centimeters per pixel, which is better than what we've done on our own Earth and Moon. So it was a huge Herculean effort to get to this point where we're comfortable handing the maps and the keys over to the spacecraft to get us down into this small site today.
Absolutely. So I guess right now it's time to say goodbye to you guys. The best of luck for today. I'm really excited, and it's great to be with you guys.
Thank you, Michelle.
Yeah.
Thank you.
So right now, I think probably the best thing to do is to check in with Gary Napier. I guess we're going to
OSIRIS are in the Y-wing configuration.
Of Arizona. Thanks for joining us, Heather.
Hi, Gary.
So what's really interesting, Heather, is that you actually feel that, long missions like this are really important. I mean, you go from design to build, but operations is really quite a while. That it's actually really important to involve that next generation and kind of bring that generation up, correct? Talk to us a little bit about that.
Absolutely, Gary, you're right. All the way back from when we started planning this mission, OSIRIS-REx, we recognized it's a long duration mission. And although that presents challenges for retaining your key personnel, we actually took it as an opportunity to use this mission to train our next generation of students and science engineers and scientists. A good example is we had one of our...
Guys, if you love this stream, just give it a thumbs up, subscribe, because on this channel, you will get all these live streams, the space events and the rocket launches of every space agency, and much more, so you can consider subscribing.
Yeah, so being at the University of Arizona
Esteban.
in the PI-led mission, we have had hundreds of undergraduate and graduate students working on this mission over the course of the last decade. And 2 of our students that started off as students are actually 2 of our navigation team members. That's Dan Wibben and Eric Sarr.
Wow,
so
they're on console.
They're on console right now. Yeah, they are.
At this time, NFT has
so
computed the checkpoint and match point burn updates to correct for errors in the trajectory accumulated since orbit departure. Checkpoint burn in 2 minutes.
So checkpoint turn in 2 minutes. We're going to throw it back over to Michelle, because I know this is an important update for her. So Michelle, thanks. Back over to you.
Thanks, Gary.
Well, absolutely. So Dante, tell us what this important milestone checkpoint means.
This is a really important part of the mission right now. So we've been hearing about natural feature tracking and how it's processing these images.
OREX MSA on OREX Ops. OREX has processed its next image. Position uncertainty is 0.46 meters.
Wow.
Right, so what it's doing with that information is it's calculating how it's going to fire its thrusters for this checkpoint. When we left orbit, we were on a trajectory that would take us over the surface of the asteroid, and if nothing else happened, we would safely fly past Bennu. Once we fire the thrusters for the checkpoint maneuver, we're actually going to start descending down towards the asteroid surface, so this means we're going to be on our way to make contact. So natural feature tracking has been doing nothing but calculating this maneuver since we started taking images.
So this is one of the big deals. This is one of the big milestones coming up.
This is huge.
Huge,
Absolutely.
I know that as we look at the simulation, there's an interesting configuration the spacecraft is in. Oh, I see the thrusters firing.
That's right. You can see we would expect right now on the spacecraft the thrusters to be firing, so we're going to be paying close attention to Dale Howell to let us know we've gotten telemetry back to telling us that maneuver has succeeded.
In the meantime, if you want to tell us a bit about the configuration it's in, go ahead.
Yeah, we heard Dale call out earlier that the spacecraft was in the Y-wing configuration. There we just reconfigured the solar arrays to get them up away from the asteroid surface, basically to protect their active areas from any dust loading that might be kicked up during the TAG event.
It's another excellent Star Wars reference.
Okay.
That's right. Always.
Looking like a fly.
You can also see here in the simulation the Nightingale sample site, now down in the lower corner here. This is our target. This is what we're trying to get into with that spacecraft.
Yeah.
And it looks like there's a lot of boulders around that.
Yeah, as we've said, generally the surface of Bennu is rough and rugged and covered with boulders. Nightingale really does stand out as a pretty unique, interesting area on the surface.
How you doing?
Doing pretty good. Paying close attention to that call out, waiting for Dale to tell us that checkpoint has occurred.
Absolutely. So what we're waiting for right now is the call out that checkpoint has occurred, and the OSIRIS-REx spacecraft has begun its descent towards the asteroid surface.
Exactly.
Right. Any time now.
And it's probably worth mentioning.
OREX MSA on OREX ops. Checkpoint burn has completed.
Wow.
Okay, we're heading down towards the asteroid surface at this point.
Really cool. I'm so excited, man.
Oh, wow. Okay, well, you know, I guess
this is
the next thing that comes up is going to be this match point maneuver. So that's the next big milestone for us.
That's right. So we've got one more firing of thrusters with the spacecraft to get us lined up for the sample acquisition event. We call that the match point because what we're doing there currently as we're flying over the asteroid surface, in fact, it's the asteroid surface that's rotating underneath us. Mm-hmm. And when we fire thrusters for match point, we're doing that to match that rotational velocity so that the spacecraft becomes station keeping, essentially, over that Nightingale sample site.
Mm-hmm, absolutely. All right, so I think we have a little bit time now to turn to our social media desk. So, James, what's going on in social media?
Yeah, Michelle, it's super exciting. You just heard that checkpoint burn confirmed. We are now just very, very close down to the surface of Nightingale. And you guys have been really excited over on social media, too, at that hashtag to Bennu and back. Lots of great messages rolling in here. Someone's really excited for our little robot friend to go rock hunting on the surface. We had someone who actually attended our launch back in a couple of years ago at Cape Canaveral and are now watching the broadcast live with us today, excited for that sample collection event. We have Philip who kind of puts it in perspective for us here. He says, this is amazing and extremely difficult in so many ways. Bennu's orbit, spin, inclination, the orbital mechanics of this long mission are just astounding. I can only imagine how many orbit simulations have been made here on Earth. It really is a crazy mission, and we also have our animal friends, our pets, cheering us on here as well. Bennu is rough from this couple of our pets here, really excited. So we're now just minutes away from that match point burn, and for that, I'll kick it back to you, Michelle.
Okay, excellent. So, you know, just a few minutes ago, Dante, you were saying that this landing site is sort of a unique area on the asteroid. Tell us about this site.
Yeah, we spent an enormous amount of effort selecting the area on this asteroid surface where we wanted to get the sample from. And we kind of divided our analysis up into 4 different categories. First, we were looking at the deliverability. And this was a real challenge because, as we've seen earlier in the broadcast, the original guidance accuracy was 25-meter radius, and we're trying to get into an area that's 10% of that size. We have solved that problem with our amazing natural feature tracking solution, and as we've heard, that's worked really well, and it has updated its checkpoint and its match point maneuvers on board based on that information. That gets you down to the surface of the asteroid. So the next thing that we have to worry about is maintaining spacecraft safety. There's a lot of hazards on this asteroid surface, things that could damage a critical component, and we decided to focus safety on the things that were needed to get the sample back to the Earth. So there were certain things we could lose at this point in the mission if they didn't fulfill that objective. We still have some upcoming major milestones that help us maintain that spacecraft safety. Now natural feature tracking is going to be switching over to calculating the contact point on the asteroid surface. And it has a piece of software on board called the hazard map. It's actually determining, is the location that I'm going to touch down on safe, a green area on that hazard map, or is it potentially hazardous, a red area on that hazard map? So as we get closer to the asteroid surface, a key moment is the 5-meter crossing. That's when the spacecraft makes that decision. Do I continue down to collect the sample, or do I back away and live to tag another day? After that, you've got down there, your spacecraft is safe. There's got to be something for you to pick up. Earlier in the broadcast, Bo Bierhaus showed us the size of particles that TAGSAM could actually collect. So we had to map the Nightingale area and other potential sample sites.
Yes, MXM, you can say that it's a flying reverse vacuum cleaner because in space there is already vacuum and we are carrying air with us, so it's kind of reverse vacuum
cleaner. We were really
cleaner.
excited to see lots of particles of that size. And of course, the final parameter that we were looking at was the scientific value. And I can tell you the good news is any sample from Bennu is scientifically valuable. We've seen these hydrated clay minerals, we've seen organic molecules, carbon-bearing minerals all over the surface of the asteroid, exactly the kind of material that we're hoping to bring home.
So I understand the next big milestone we're looking for here is something called match point.
That's right.
So what happens at match point?
Match point is the final maneuver that the spacecraft performs by firing its thrusters. And that's where we become centered over the Nightingale sample site and begin that final descent down to the asteroid surface. And the spacecraft is solely focused on its safety calculation and the decision on whether or not it's going to proceed down to collect that sample.
Of course, the amazing thing about match point is that the asteroid itself is actually rotating. So when we go to match point, the spacecraft has to match the rotation of the asteroid so it comes directly down onto it.
That's right.
So how fast is Bennu rotating?
Bennu has a rotation period of 4.3 hours. So that's basically the length of the day on the asteroid. On Earth, the rotation period is 24 hours, which is why a day on Earth is 24 hours long. So that translates, because Bennu's a pretty small object, as we've seen, 500 meters or about the same size as the Empire State Building. At the equator, the surface is moving at 10 centimeters per second. It actually gets slower and slower as you go to higher latitudes. By the time you get to the North Pole, it's 0. Nightingale's pretty far north, so it's actually much slower than 10 centimeters per second. And that just kind of shows you the delicate precision nature of this mission. You know, we've got to get very low thrust maneuvers, very delicate, very slow approach to the asteroid surface. Everything kind of happens in slow motion when you're operating in a microgravity environment like Bennu.
So what's the next critical milestone after match point?
After match point, we're going to be looking for the natural feature tracking system coming back online, taking those images and additional correlations and precision on its knowledge of its position. And we might expect it to actually jump up. We've been hearing natural feature tracking uncertainties on the order of ½ a meter. It may go up a little bit as it goes through.
On ORX Ops. ORX Natural Feature Tracking System has resumed processing.
Wow.
Position uncertainty is 1.6 meters.
Oh,
so
okay.
You can see there we went back to 1.6 meters. That's because we went through the checkpoint maneuver. So whenever you impart a thrust like that, it adds uncertainty into the system.
Exactly.
And we're seeing that with the natural feature tracking system right now.
That's
where is it? We'll just go and land.
We're going to introduce, actually, the Associate Administrator of NASA, Dr. Thomas Zurbuchen. Thomas, thank you for joining us.
So glad to be here with all of you.
It's an exciting time, Thomas.
Happy birthday.
Guys, if you just love what I do, you can consider supporting me on Patreon. And link is down in the description. It really helps in managing my funds. Thank you so much.
It turns out that there have been a lot of friends, a lot of colleagues that have helped get us to this moment. So, you know, who's been along with us on this journey?
Well, look, I mean, there's a number of course, domestic partners, many of them around here. You talk to some of them, but there's also international partners. And the Canadian Space Agency provided the laser altimeter, which is an important instrument here. And of course, we have a partnership with JAXA. What we're going to do is actually share the samples from Ryugu, from Hayabusa 2, with OSIRIS-REx once it's back for maximum science. And that's really what international partnerships are about.
So this is a big mission for NASA, but it turns out that there are many different kinds of partners in a mission like this. Give us a sense of the range of partners that we have.
Well, look, I mean, it starts with the University of Arizona. That's where the leadership is, and with you there and your entire team. But NASA Goddard Space Flight Center is a critical partner with managing, of course, especially also working with Lockheed Martin, who really, you know, with that team deserves a lot of credit, and Kinetics, which was already introduced, as well as many others. You know, if you really look, so often missions like that.
Guys, if you just love the stream, give it a like and subscribe maybe for latest updates.
And we will see you later on in the program.
How do you feel, man?
I'm pretty excited. This is the final
Me too.
like 10, 12 minutes here for contact. I feel really good. The team's in high spirits. As you and I talked about earlier this week, we have done everything possible to make this today a success.
Exactly. It's been 4 years.
And, you know, Your
since
mine
this
is
has
already
been
out
launched,
there, and the spacecraft is
and
already on the way
20
out.
years
and
of
the
planning,
Spacecraft
deciding,
is back.
execution.
It's good actually to point out whatever has happened with TAG has already happened. We're well past that 18.5 minute runway
Yeah,
time.
exactly. That's the
Absolutely.
thing.
Congrats. Let's continue doing this.
Yeah, we'll see you later. Thank you, Thomas.
Yep.
Oh, wow. Okay, so we're coming up, I know, on the critical point of match point. So at what point will we know that we really have a sample?
That's a great question. We're not exactly sure what's going to happen right away. We'll know if we made contact with the asteroid surface today. We'll know if the gas bottle fired, and we know that we backed safely away from the asteroid. But we actually have a lot of work to do over the next week or so. We'll take a look at the images that we were acquired during contact with the asteroid surface, and then we'll go into a different imaging campaign. We're about 30 seconds from match point, so we're going to keep our ears open for that critical call out from Dale.
OREX MSA on OREX Ops. OREX has processed its next image. Position uncertainty is 1 meter.
All right.
Okay.
We're back down to a meter positional uncertainty. That's great news. So back to sample verification. We will, after we're well away from the asteroid and everything has kind of settled down, we have that robotic arm. We're actually going to use that to put the TAGSAM head into the field of view of SAMCAM. And we can look not only at the top of the sample head,
as you
like
can
we're
see,
gonna get
guys,
with
this
the
is the
images
real-time
today, but we can
simulation,
actually turn it
and
around, and we
the
can look at the
thrusters were
base
firing,
of
and now it is
TAGSAM.
not. So
We have,
I think it has been
gas
completed.
Stimulation, we have contact pads. Simply by making contact with the asteroid surface, we think we can pick up fine-grained particles, less than a millimeter or so. But basically, we're going to be looking for any evidence of asteroid material on or inside the TAGSAM.
Now, obviously, you don't want to go all the way back to
OREX
Earth without...
MSA on OREX Ops. Match point burn is complete.
Wow.
Right.
We are finally going.
We've got about 10 minutes before contact with the asteroid surface.
Oh, wow. So I was about to say, so obviously you don't want to head back to Earth with not much sample. So how do you know how much sample you actually got?
There's an incredibly clever physics experiment that the team has designed here called the sample mass measurement. So what we're going to do is we're going to place the spacecraft arm out to the side of the spacecraft. So it's in sampling configuration is actually pointed above. For this, we point it out in the other direction.
So
and we kind
hello
of
for
spin the entire
Ireland. Okay,
spacecraft
so we
around.
have world
And we're measuring a
people
property
from
called the
all over
moment
the
of
world
inertia.
watching.
We have actually already
Thank you
done
so much
this,
for your
prior
support.
to initiating the tag
And
sequence
let's
today.
see what happens.
So we know what that property is when the TAGSAM head is empty. Now we're going to be able to do it, hopefully, when it's full of asteroid regolith. So we're only looking for small differences in this property as a result of this experiment. And the precision, just like everything on this program, is phenomenal. We're talking tens of grams of precision on a measurement on a spacecraft hundreds of millions of miles away that just picked up this asteroid sample. The minimum that we're looking for is 60 grams, or about
OREX
2
MSA
ounces.
on OREX Ops. Attitude control system has transitioned to touch and go mode.
Right, spacecraft's getting ready to make contact with the asteroid surface
Wow.
here. So the sample mass measurement
can
will tell
see
us
the
if we have
simulation,
60
guys.
grams or more of material, and that'll happen on Saturday later this week.
Hi, Gasha Grace from England, and Ricardo says he chanted, I don't know Spanish.
So we're going to listen to the flight controller calls from MSA, but before we actually touch the surface, it's a great time to visit our social media desk again. So, James, what's going on?
Yeah, thanks, Michelle. So you've been hearing those call-outs from Dale over the loudspeakers about those NFT images processing. It'd be awesome to actually grab a camera and make the trek out to Bennu to photograph it up close in person. But, you know, as we've mentioned, Bennu is a little bit far away from us right now, on the order of 200 million miles away. But Bennu around your head. The second one is called To Bennu and Back. It allows you to place an asteroid wherever you are, at home, at school. Bring an asteroid with you. So I understand we actually have a question coming in from Instagram from Mauricio, who asks, how do you manage the force back from touching down? I mean, the moment the spacecraft touches the surface, it should experience a similar force in the opposite direction.
Exactly.
How do you manage that? Well, thanks, Mauricio. So the team actually thought ahead for this one when designing that sample arm. They actually added the spring-like mechanism to it that you can think of a bit like a pogo stick. If that sample arm were rigid, when contacting Bennu, it would stop its downward motion, and when firing the gas bottle to stir up a sample, we would just kick right back off into space, as Bo Beer had.
Okay. So I think some problem with the stream, guys. Just a sec.
How do you manage that? Well, thanks, Mauricio. So the team actually thought ahead for this one when designing that sample arm. They actually added the spring-like mechanism to it that you can think of a bit like a pogo stick. If that sample arm were rigid, when contacting Bennu, it would stop its downward motion, and when firing the gas bottle to stir up a sample, we would just kick right back off into space, as Bo Beer has.
So I think there is some problem back end, and let me just really quickly switch over to another stream wherein the connection
Down to
should be
2
stable.
centimeter per pixel resolution.
Okay.
And as was mentioned earlier by Coralie, that
This
is
is
actually
good.
higher resolution than we've actually imaged our own Earth and
Okay.
Moon. So really, really beautiful imagery, and I definitely encourage you to check that out. But we're just minutes away from this actually happening in real life. So for that, let's kick it back to you, Michelle.
Okay, thanks, James. So, Dante, I want to ask you a couple personal questions here. You've spent about a third of your life working on this mission. What are you feeling now?
It's a pretty amazing emotional state,
Exactly.
Michelle. When you get to
I'm
a point
also
like this
feeling
in your career, an event that you've worked for, in my case, over 16 years to get here, you kind of think back to all the people who have helped you. I think about my family. I know they're watching from Tucson, Arizona right now. They've been really important to me. And another person who can't be with us here tonight, unfortunately, is my mentor, Dr. Michael Drake. He's the one who invited me onto this program in 2004 to be his deputy. I was a young, bright-eyed assistant professor. And we worked together for 7 years writing proposals to convince NASA that this was a program to fly for New Frontiers 3. We won the contract for OSIRIS-REx in May of 2011, and Mike passed away September, a real blow to the team. So I miss him. I wish he was here today.
Yeah, yeah. It's very real. I mean, you know, we're connected to our avatars that we put out there in the universe. So,
Yeah,
yeah,
I know he'd be proud of us,
Yeah.
and he would really love it to be with us right now.
Oh wow, we
so
can
we're looking
see
at sort of
that.
an amazing simulation right now. So
Wow,
you know, as
it
we
should
mentioned
be
before,
good.
these are not actual images from the spacecraft,
simulation,
but these are
exactly.
based on a huge amount of real data. So we're actually looking down as this TAGSAM instrument starts approaching its sample site.
Yeah, we are collecting tons of images right now, but we simply don't have the data rate to get them back to the Earth in real time. So they're just getting banked into the spacecraft's memory, and we're going to start looking at those later tonight and have them available for everybody tomorrow morning. So this is just a simulation of the field of view of the SAMCAM, the sampling camera, part of our OCAM's camera suite. It has a clear shot of the TAGSAM collector right in the middle of its field of view. You can actually see the lower end of the TAGSAM arm here.
OREX MSA on OREX off. OREX is descending below 25 meters.
Wow,
Getting really
it's finally
close.
going,
I
guys.
want to remind you, it's the 5-meter crossing.
Yeah.
That's the really critical one. We're only a couple minutes away from that.
Exactly,
So
I'm
the
so
spacecraft
excited.
has one key decision left to make. It's calculating right now the
Hazardous, yeah.
probability that it's going to come down either on a hazardous area, as we defined on that hazard map, or
Thanks
in
for
a safe
subscribing,
area.
Israel.
So we may, at 5 meters, the spacecraft may decide that it's hazardous and it's going to back away, allowing us to live to tag another day. So to me, all my senses are on that call out right now.
Yeah.
I really want to
I have
hear
literally
that we are
crossed
go for
my
tag,
fingers
so that's
now.
just a couple minutes away here.
I'm so
And of course,
excited.
remember that was planned for. That you know,
That's right.
It has to know it's safe, otherwise it's going to back up and try again another time.
That's really how we solve the amazing challenges that this asteroid surface presented to us. You can see
Wow.
here that this is a pretty daunting terrain that we're coming down here. There's giant boulders all around the Nightingale site, even some large rocks inside the crater that we do not think the spacecraft would survive, at least with the ability to return back to Earth and make contact. So it is there
Thanks,
to
Peak
protect
Gaming,
itself
for
first and
subscribing.
foremost. Safety is always
2
first.
minutes from the
but
touchdown, guys.
We're feeling pretty good. Everything's gone really well today, so I would say things are
Thanks,
looking
Regis.
great for a
Regis,
tag.
hey.
But of course, the spacecraft is the one that gets to make that decision.
It's just amazing.
Thanks,
We've been
Jason.
rehearsing this event, you know, all week long, all the different
For
mission calls and
subscribing.
milestones, but then to actually be here tonight and
2
realize that
minutes
this is
until
going on
this
200 million
go
miles
for.
away.
That's right.
Oh, I'm so
Yeah.
excited.
I'm pretty
Can we
excited.
see the simulation
So, I mean,
in
there were
real
obviously a lot
time?
of
I mean,
firsts in this mission.
OREX MSA on OREX ops.
okay.
OREX has processed its next message. Position uncertainty is 0.5 meters.
Wow.
Predicted tag lateral offset is 1.7 meters. Hazard probability is 0%.
Wow.
Tag lateral velocity is 0.2 millimeters per second.
Oh my God.
Tag vertical velocity is 10.2 centimeters per second.
That sounded
Wow.
really good.
This
Yes.
is good,
Sound like
really
the hazard
good,
map
guys. This is
calculation looks
happening.
really good.
This is
we're
happening
coming down
now.
in the green
I'm so
area.
excited.
We're going to make contact with the asteroid surface.
Fingers crossed.
Wow, so remember how historic this is NASA's first mission to retrieve a sample from an asteroid,
Yeah.
a pristine part of the solar system.
That's
Just
right.
look at that animation now. So we're looking
I'm
at
looking at the team. I think that, we can see everybody
Can we
is
see
laser
the
focused on
animation?
what the spacecraft's going to do. So I say let's let this play out.
Thanks, Kenneth. And here we go. I think
But those calls were really great. That was great news from Bill.
Thanks, David.
even more accurate than we'd hoped for in some cases.
Wow, wow, wow. It is happening. Thanks, Jacoby. Can we see the simulation?
Seems happy.
Please.
So I guess there were obviously a lot of firsts in this mission, and there was a time when you said a lot of what ifs basically. I mean, what if we could actually send a spacecraft to an asteroid? What if we really could bring back a sample of the solar system from billions of years ago? Did you remember where you were when those what if
OREX
questions?
MSA on OREX ops. OREX has descended below the 5-meter mark. The hazard map is go for tag. Contact expected in 50 seconds.
50 seconds. Okay, guys, this is happening. So the timer was
Touchdown
wrong, but
declared.
it's happening finally. It's happening. It's
Right.
happening.
Sampling is in progress.
Sampling is in progress. Wow, wow, wow. Literally wow. I can't believe.
Oh my gosh, we're there,
Wow.
folks. That was amazing. I mean, I
Wow.
don't know if you saw the team here, but they just kind of blew up. They went from being steely-eyed to like celebrating the Super
seriously,
Bowl.
man.
So it's all good. This is amazing. So congratulations, everybody. I know that Dante and Dr. Zabrukin are right here. And Dante, you somehow got over here pretty quick.
Sure did.
Wow.
Congratulations. How you guys feeling?
Transcendental. I mean, I can't believe we actually pulled
Mac.
this off.
This is so cool, man.
Hey, do you mind if I just bring up something?
Please.
Our friend Mike Drake is with us right now.
That's
the
right.
guy who came up with the mission at the beginning, and we're thinking of him. He's no longer on Earth, but I feel him right here.
I agree. He's with us today, and I know he's incredibly proud of this team and everything we have accomplished. This is history. It's amazing.
God, I can barely speak. I'm like shaking. How about you?
Absolutely. It's almost hard to process everything that's happening right now. It's overwhelming pride in this team and everything we've done to get here.
Thanks,
I
James, for subscribing.
Really have anything better to say about this group of people.
Thanks, James.
OREX MSA on OREX ops. Sample collection is complete, and the back-away burn has executed.
This is going.
All right.
We're on our way back.
Touchdown confirmed, guys. This is so cool.
Now, Dante, that was actually a really important call. We were celebrating on the tag, but that was actually probably even more important call. Why is that?
The pyro bottle's fired, so TAGSAM operated. The back-away thrusters fired, so we're safely moving away from the asteroid surface. The spacecraft did everything it was supposed to do. So we did it. We tagged the surface of the asteroid, and it's up to Bennu now to see how the event went.
What does this mean to NASA?
Oh, I mean, this is...
This is so cool, guys. It is successful. It
to
was.
figure out how much we caught of this amazing sample that
That's
we're
right.
thinking about for decades. But I think this is just... I'm so proud of this team. Hey, team.
It's been 20 years of, and social distancing is to be followed. They can't just hug, and I would love to see them celebrating to their full potential, but I can't just
I
believe
gotta tell you, this has
myself
been
also.
a
This is
fantastic day, a fantastic journey. We're so proud of both of you for
Wow.
being here and supporting that team. We're going to get back over to the stage
Congratulations,
and
NASA.
Michelle, but
You
some
are
really good news.
Contingency.
Back
Thanks,
to you,
Sarah,
Michelle. Thank you.
for subscribing.
This is one of those moments we're all aware of COVID-19 because I want the hugs and the high fives and
Yes.
everything, but we're all going to keep each other safe. There are lots of super excited people all over who want to share in this moment and share their congratulations.
No kidding.
So let's take a moment to hear a few words from 3 institutional leaders who couldn't be here tonight, but they're cheering on the team on behalf of so many supporters.
Hi, everyone. Dennis Andrusik, Goddard Center Director.
Wow.
I am just so excited
Guys,
that OSIRIS-REx
this is
is
so
collecting
cool.
a sample from the surface of Bennu. the tag is just
the world is here watching this stream, guys. I can
getting
just
sample back to Earth is obviously going to be a great event of the entire mission. But I got to congratulate Dante, you and your team, your project management.
It has completed its departure burn, guys, and
Rich,
thanks
the
for
operations team,
subscribing.
for getting us to
And
where we are. And Lisa Callahan for the awesome Lockheed Martin team.
This is so cool.
Getting OSIRIS-REx to where we are.
We are just living in
building
this
a great spacecraft
world, this time.
and returning it to Earth. Go OSIRIS-REx.
Go OSIRIS-REx. Go NASA.
Today's an exciting day. As OSIRIS-REx begins its descent
From
to Bennu,
okay,
the nation is looking
congratulations,
forward to the
Alberto
news of a
says.
successful TAG event. OSIRIS-REx team members have been working on this project for more than a decade, and the work being done is hard, and it's complicated, and it's necessary. Understanding the makeup of Bennu will help us better understand our universe and how to protect our most important asset in space, Earth.
Exactly.
I want to wish the best of luck to the entire OSIRIS-REx team, including our partners at the NASA Goddard Space Flight Center, the University of Arizona, and especially the mission operators and engineers right here at Lockheed Martin. Go OREX.
Yes, Luis Carter, we are also
The
looking
University
for
of
the
Arizona
pics.
is incredibly
guys,
proud of
what
its
will
long
happen
tradition
is-
of excellence and leadership in space exploration. I'm thrilled to see the OSIRIS-REx's mission's achievements.
So now they will basically first obviously they will achieve the orbit, and then they will see if they have enough sample by measuring the moment of inertia. Thanks for subscribing, Rita. Really appreciate that. And then if it is greater than 60 gram, then they are ready for the departure, but that will happen March 2021.
After some excellent news, I'm here with an exultant Dante Loretta from the University of Arizona. So one more time for our audience out there, explain when we know we'll have a sample.
A little overwhelmed right now, Michelle, I have to say. It's been pretty intense several minutes here. I can tell you that everything went just exactly perfect, which is kind of the hallmark of this team. We have consistently beaten expectations over and over again. We have overcome the amazing challenges that this asteroid has thrown at us, and the spacecraft appears to have operated flawlessly. We made it down to the asteroid surface. We were in contact.
It will be in the orbit.
The gas bottles fired.
Asteroid. Okay.
We don't know how long we were in contact with yet. That's some reconstructed information that we're going to have to put together over the next few hours as the data come in. We backed away successfully from the asteroid surface. The team is exuberant back there. Emotions are high. Everybody is really proud, and we have some work to do to determine how much sample that we have collected. The next thing that I'm going to be looking for is once the spacecraft cools off, it probably got pretty warm as it approached the asteroid surface, so it needs to get rid of some of that excess heat. It's got to get those solar rays back onto the sun and get power positive. Once it's stabilized, it's going to point that high gain antenna at the Earth, and we're going to start bringing that data back. And those SAMCAM images are going to tell us an enormous amount of information about how the events of today went. We're going to be looking at a whole series of images as we descended down to the surface, made contact, fired that gas bottle, and I really want to know
till now, you can subscribe, because in this channel only I'll post those images, those videos, whatever NASA will release, I'll collect and post it on this channel. So if you are into that, you can just consider subscribing, because in this channel we host live streams of every rocket launch, space events that happens in the space industry, no matter what country, what agency. We host that. Also, we have some great videos on rocket science, and you can just check them out. So if you are that kind of guys, you can consider subscribing.
Kudos to this team. It's an amazing experience.
Oh, wow.
And history was made tonight.
Absolutely.
Sure.
Exactly.
So, you know, what we're going to do now is actually take a closer look at this beautiful terrain that we've actually sampled. We've identified over 1 million asteroids in the solar system. But remember, Bennu is what's called a NEO, a near-Earth asteroid. So instead of orbiting in the main asteroid belt between Mars and Jupiter, it has an orbit fairly similar to our own planet, Earth. And it not only gets our attention because it's so close to Earth, but also because we believe it may be one of the older bodies in the solar system with a wealth of information about how the solar system and life began.
Together.
Let's take a closer look at the subject of all of this activity, all of this joy
Thanks
tonight.
for subscribing.
Let's take a tour of Bennu.
ASWWSK. Okay, so geologists have a saying, rocks
December 2018, after traveling for 2 years, 101 days, In over 1.2 billion miles, NASA's OSIRIS-REx spacecraft arrived at its target, near-Earth asteroid Bennu. OSIRIS-REx is the first mission to explore this primitive remnant from the origins of the solar system, designed to study the asteroid and return a sample to Earth. Bennu is a dark, diminutive world, roughly the height of a skyscraper, and now the smallest body to be orbited by a spacecraft.
Exactly.
Prior to arrival, it was known to have low thermal inertia, a characteristic of fine-grained materials like sand. An infrared spectrometer on OSIRIS-REx confirmed this property, leading scientists to expect a predominantly smooth surface. But the first close-up views of Bennu delivered a major surprise. In exquisite detail, the mission's cameras revealed an unrelenting rockscape dominated by boulders. By combining these images from OSIRIS-REx with its laser altimetry data, we can take a tour of Bennu's remarkable terrain. The first stop is TAGSAM. This prominent boulder defines the asteroid's prime meridian and serves as the basis of its coordinate system. In Persian mythology, the Simurgh is a large and benevolent bird and the possessor of all knowledge.
Looks
TAGSAM
like a frog.
is Latin for stone.
Why does it look like a
To the
frog? I don't
northeast
know.
lies the largest boulder on Bennu. Measuring over 300 feet in length, rock TAGSAM is a colossus longer than a football field.
Wow.
It is also rich in a type of iron oxide called magnetite, which was used by mariners as an early form of magnetic compass. In Arab folklore, the rock is an enormous bird of prey that can clasp elephants in its talons, as well as stranded sailors, like the hero Sinbad. Continuing northeast over the equatorial ridge, we arrive at Gargoyle Saxum. This striking boulder is among the darkest on Bennu, though it clutches a much brighter rock that is about the size of a person. In medieval legend, gargoyles are dragon-like, winged monsters that can breathe fire and that guard cathedrals from evil spirits. Our next destination takes us far to the east. At the northern end of a small crater lies Acronym Saxum, a comparatively bright boulder measuring about 33 feet in diameter. Acronym Saxum is located near one of 3 sites where Bennu ejected small particles into space in early 2019, displaying its dynamic and evolving nature. In Greek mythology, Acronym is one of the 3 harpies, the half-maiden, half-bird personifications of storm winds, who would carry evildoers away from the earth.
Okay. So let's hope it
In the
is.
creation stories of ancient Egypt, the universe began as a formless, endless expanse of water. From this primordial sea arose the primordial mound, Benben. It was upon this rock that the god Atum settled in the form of the Bennu bird and sent forth the call that shaped creation. The story of Benben harkens to the mounds of fertile silt that once emerged from the receding floodwaters of the Nile, and it provides a fitting namesake for the tallest boulder on Bennu. Protruding by over 70 feet, Benben Saxum is so tall that it was first detected from Earth. Now, we can appreciate this monumental feature in detail using data from OSIRIS-REx. The final stop on our tour is a cluster of exceptionally bright boulders scattered across the southern hemisphere. They bear the spectral fingerprint of pyroxene, a mineral found in igneous rock that is unlikely to have formed on Bennu. These boulders most likely originated on the large asteroid Vesta and were delivered to Bennu's parent body through meteoroid impacts. Although it is small in size, Asteroid Bennu has proved to be a fascinating world, abundant in geographic features that have defied our expectations. Thanks to OSIRIS-REx, we can now explore Bennu to uncover its composition, its evolution, and its ancient memories from the origins of the solar system.
Okay. That's kind of cool.
And if everything has gone right tonight, a little bit of Bennu will be coming back to Earth in 2023. So let's get one last visit with our social media desk.
Just give
James,
me
what's
a
going
piece
on?
of that.
Yeah, Michelle, I've got goosebumps. I really can't even begin to fathom that we just tagged and collected a sample from this asteroid 200 million miles away. I know I'm going to want to relive the events that just unfolded tonight, and I'm sure you will as well. So once again, we have that 360 video up on our NASA Goddard YouTube page. Go check it out and put yourself right where the action just happened a couple minutes ago. It's truly mind-blowing stuff. I also want to check back in with that Twitter poll that we put out at the beginning of the broadcast, and we were asking you how much material you think we just got from Asteroid Bennu. So remember, we're looking for at least 60 grams, but that sample container can hold up to 2 kilograms. So yeah. You guys are saying that a candy bar size of sample. I like the optimism. Let's hope we actually pack that container to the max and bring all the sample back home. But any sample we get back is truly magical and will help us learn more about the solar system and our origins here. So keep at us on the hashtag to Bennu and back. We're excited to keep this conversation going as we look to bring that sample all the way back from Bennu here to Earth in 2023. So back to you, Michelle.
This is one of these evenings where it's such a privilege and a pleasure to be working for NASA and for the idea of scientific exploration. So what we've been doing all evening is seeing the joy, seeing these people that have worked on this for decades. But you have to remember there's a real reason we're going to look at these asteroids. We think we actually might be coming back with a baby picture of what the solar system was like, of what our chemistry was like billions of years ago. We're looking for our own origins out there, and that's why we've gone so far to bring a bit of Bennu back. This has been an incredible evening. The adrenaline, good night.
Okay, so guys, wow, 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 and wow. What we just saw, I can't just even tell you guys. This was such a beautiful event, and this was successful, and the time which we are living right now is so beautiful. I know it's 2020, I know everything happens, but in 2020 only this beauty has landed on the asteroid and collected the sample. I'm just now hoping that the sample is fully, you can say, acceptable, as in the amount of sample we have collected, it's greater than 60 grams, and we are able to get it back successfully and finally analyze what is there when for with what was there 5 billion years ago, because that is 4 to 5 billion years old asteroid. So that would be very amazing to see. So, and Karan Pradhan says this was epic, mate, and you missed it. Well hosted stream by NASA. Okay, so thank you so much for your appreciation. And because if you are just new on this channel, let me just tell you that on this channel we host live stream of every rocket launch that happens in the space industry or these kind of space events. So if you are that kind of guy who likes everything in one spot, then you can consider subscribing. Also, we have some videos on rocket science, SpaceX, ISRO, NASA, everything. So yeah, that's the thing. Wait till 2023 for the sample though. Yes, Karan, that's how orbital mechanics works, I should say, because we have you know guys what is launch window and everything. So the launch window for the Earth return is opens in March 2021. So what will happen right now, it will just collect the sample and stay in the orbit of the Bennu. So the orbit of the Bennu in which it stays, uh, okay, thanks Roxil for subscribing. So the orbit of the Bennu which in it stays is very stable. Thanks John for subscribing. It can just be in that orbit for months without any navigation needed. Thanks Miss Meme for subscribing. Total waste for money for some dust could have just hovered by okay, no, it's not a waste of money, because once we know how it forms, how the Earth, the solar system was formed, how the life actually started, and also what is the composition of that.
However,
okay, so let me just switch over to this.
We're here, there.
So thanks for so much for subscribing, Seema Das Gupta. Thank you so much for subscribing. And now let's just have a look. Now let me just talk about it, because I'm so much you can say happy that this thing has finally been there, and we were able to see it. So guys, it is not a waste of money, because finally we know that it will someday somehow one asteroid will come in direct collision with Earth, and we should know how to stop it. And this is one of the hazardous asteroids astronaut. And so we should know what is the composition, what is material it is made up of, and so we'll be able to redirect it and change the orbits. Thanks Blebu for subscribing. And I'm not mistaken, they can try it for 2 more times if the sample isn't up to 60 grams. Yes, Karan, it is like that only. If the sample is not correct, they will consider, you can say, having more sample. And we actually, yes guys, I am just amazed. So how we can just go 200 million miles away, complete everything successfully, and doing that. Thank you so much for subscribing, guys. Mauricio Kabira, if you are just joining in, on this channel we host live stream of every rocket launch that happens in the space industries, and the space events like you just saw, and the rocket science and space related videos also you will find on this channel. So if you are if you love all these and want to have everything on one spot, then you can consider subscribing and consider supporting me on Patreon also. So this is the OSIRIS REx spacecraft, guys. If whatever you just saw, let me just summarize and make you see how everything would have happened. So this is the asteroid Bennu, as you can see here, and this is the spacecraft. So this is the tag, which is, this is the tag, yeah, kind of like this only. And this is what has gone and touched down the surface. Thank you guys for subscribing, really appreciate that. And what will happen now? Now since it has collected the sample, so what will happen now once it has achieved the stable orbit, which you can say, I am not mistaken, let me just over to, yeah, can we see the orbit of the OSIRIS? Can we? No, we can't. Okay, no problem. So okay, it's okay. So now what will happen, guys? It will just put the it's there. So now there are some instruments you can see here. These are the cameras. It will picture the sample whether it is good or not, and then it will perform a spin maneuver. This spacecraft will perform a spin maneuver, spinning on its axis. Now since this is extending out, so we can measure the change in the moment of inertia from when it was empty, and when it is there, when some mass is there here in this collection tube, uh, it will spin and measure the moment of inertia. And the change of moment of inertia, we can tell how much weight it has collected, because in space we don't have a weighing scale or something like that. You must be wondering, then can't we just bring take that weighing scale which we have here on Earth to on the spacecraft and just put it on there, and we can have this readings, right? No, it does not work like that. The weight which we get here on Earth also is the product of mass into gravity. Gravity is must to have weight, okay? And otherwise we are just made up of mass, and mass can't be measured. So if you want to measure, yeah, mass can be measured, but there are some different thing. But it's not as simple just putting on something on the weighing scale and measuring. No, it does not work like that. So that's why they have considered this thing by measuring the moment of inertia. I love that. Moment of inertia, if you don't know, is basically the, you can say, the change in angular momentum, the momentum in when we are rotating. And yeah, so plot twist, and everyone is there. And okay, so guys, if you have any questions, you can just ask me. The way they are going to calculate the weight of the sample that they collected is simply mind-blowing. Yes, Karan, that is true. And we all are amazed at the success of this mission. Karen, thank you so much. Yes, it is, because one more mission is there, guys. This is not just one means they have many missions planned in the coming years to the asteroids and all. So one important one is the DART mission, which will actually demonstrate the asteroid redirect mission. How can we redirect the asteroid to avoid the collision of the Earth? So what is happening? The DART mission, hopefully it will be happening in the next year. So there is one asteroid which will be passing by, flyby, which will perform a flyby from the Earth, near the Earth, I should say. Okay, so this spacecraft will get there. Now that asteroid has a mini moon. Okay, that asteroid has a minimum. Basically, you can see, you can just imagine, if this is a bigger asteroid, then we have a smaller asteroid which is orbiting that thing. Okay, bigger. So what we are planning to do, in what NASA is planning to do in that mission, is that they will try to alter the you can say, they will try to play with the mini moon. Because of the gravity of the mini moon of the that asteroid, they are hoping that they can change the orbit of the asteroid, because the asteroids are in a sun synchronous orbit, and they are very, you can say, they weigh less than the planets, obviously. So just a small amount of force can alter their orbit by, you can say, millions of miles. So that's why we are just considering that. And this Bennu has, you can say, proved to be a foundation stone for all these missions to come. And then after we have studied all these asteroids, how they perform, what is their orbit, and you can say how we can track them, then finally, and there comes the $1 trillion man, whoever will be the whoever, you can say. Okay, so let me just tell you this thing. uh, if I'm not wrong, one guy said that the world's first trillionaire will be that man who has the company of asteroid mining. Yes, asteroid mining. And the mining is basically, uh, asteroid has ample amount and huge amount of resources to mine: gold, platinum, water, whatever resource you say on Earth, you can find it on asteroids. But they should not be living one. Grass, you, or the plants, you just can't find on asteroids. But yeah, there are other minerals and rocks you can just find out. And if we can mine it and bring it back to Earth, then that guy will be the trillionaire, whoever owns that company, because the asteroids are unlimited, theoretically unlimited. So we can get access to unlimited resources. We can get everything back to Earth. They just need to figure out how to mine it, how to bring down the cost, and all those economics. And but if they get it, it will be a huge milestone. So this, let me just see. Now they are waiting to receive the data. Yes, they are waiting to receive the data, and hopefully they will receive the data in the morning. They will analyze everything right now. I think it's all fake. No, it's not. Congratulations, NASA. Yes, Lenel, congratulations. The stream is actually not that bad, but I can't listen to that terrible accent. Okay, sorry. Okay, no worries. Your wish. And so yeah, I was talking about this. Now let me just throw some facts about this mission. So this is around 200 million miles away. This spacecraft is around 200 million miles away, and this one signal to come and reach that uh, spacecraft takes 18.5 minutes. So it is that far away. So whatever you just heard, all those milestones have already occurred 18.5 minutes past. So that's the thing. And they will confirm the sample collection data by Saturday. Yes, Karan, you are right about it. They will surely confirm that. And now let me just pull over the more important things, or you can say the more exciting things, so that we can have some look at it. So yeah, I was talking about the navigation. How does this spacecraft navigate for this? So first of all, guys, if you don't know, in the simulation, as you can see in the animation, this is kind of very smooth and plain. This is what they initially thought the Bennu would be. Okay, so whatever the mission they have designed, whatever mission they designed, they kept in mind that this thing is plain, sandy, it will be easier to collect it. And yeah, so to maneuver that and to navigate the spacecraft near the asteroid, they had the lidar system installed in there. Lidar is basically it's a hardware solution to navigate. Okay, so but they also had one thing which you heard today also, NFT, natural feature tracking. Okay, but that was that was basically a secondary instrument. If lidar fails, then they will use that. But since when they got near to the asteroid, they found that it is very rugged boulders and all those rough surface, they actually switched over to the natural feature tracking only as their primary source of navigation. They initially planned that lidar will be there in you can say the primary source of navigation, but they switched over to the NFT. And I'm so much, you can say, uh, they were so much lucky, or you can say planning was like that. I don't know, but the feature, the NFT, if they haven't installed it, because that was secondary thing. If lidar would have failed, then only it would have functioned because of with that. But they just installed that thing in here, and now that became the primary thing. So weird things happens in space. And yeah, so let's just compare the size of this. So here we go. You can see here the human standing in front of it, floating in space. That's the size comparison. This spacecraft is kind of huge. The size comparison you can see. And if we consider the size comparison with the bus, it looks like kind of size of a bus. Yeah, I think so. We just ignore the this thing, breadth or width, whatever you say. The size is kind of that. And what is this? Oh, football stadium, obviously. Okay, so I think this football stadium would be interesting to compare with this thing. Let's just compare the football stadium with this thing. Here's the football stadium. Okay, so as you can see, this stadium is very small as compared to this asteroid. Maybe they said this is a size of 5 football stadiums. And is it a football stadium? Oh, it's a rugby stadium. Sorry, I don't know which stadium is there, but some stadium. I don't know, but you can see the size. And as you can see here, this asteroid spins about its axis. And why these spinnings occur? So let me just switch over to that. Okay, if this is working. Yeah, we have this thing here. And now just a sec, more interesting things to come. Video of asteroid Saturday. Just be patient. Yes, I really thought they were gonna have video of it landing, so I'm kind of disappointed. And they had the simulation, but the thing is, they can't just transfer the huge amount of imagery. You have satellites in here, right? Your satellites to download the images at megabytes per second, 3.5, 10 megabytes per second for the video and that. But they don't have satellites in space. How will they have the internet connection to download the images? They really need to have a very big antenna for a spacecraft to work at 200 million miles, and to transfer the data from that range back to Earth, it really requires some huge amount of power. And that's why there only a low gain antenna was working, just providing a crucial amount of data during the touchdown. But everything is recorded. Now, once it achieves the orbit, it will point the high gain antenna back to the Earth, and the NASA will be able to download the images, videos, and everything. And hopefully tomorrow they will release that. And on this channel you will find that. Okay. So now let me just Hola Edgar, and sure, money spent in collecting a rock. Ricardo, it does not work like that. And yeah, now Trump aware of this? Yeah, obviously. Why not? He only approved. He must have a no. No, he didn't. It happened in 2016. The launch happened in 2016, and the planning was happening 20 years back. So no, this was previously approved. Now, so where is that? Okay, just a sec. Let me just. Yeah. It would be great to see some images from the spacecraft, right? So let's just do that. What are the instrument it is carrying? Let's just if you want that, we can have that, but yeah, you guys must not be interested in that. So okay, let's just switch over to this thing. Yeah, images. Loading, loading, and loading. Okay, let's have this music also going in the background. It would be great. Come on, man, load up the image. Why aren't you loading the image? Got the spacecraft. Okay, no, I don't want to. Spacecraft imagery loaded up, filter by instrument, all. Not happening. But I have some other things in mind which we will follow. Here we go. There are some cool images, and now I am going to show you. Let's switch over to that now. Okay. So yeah, here's the it is not the image which I was supposed to show. This is the OSIRIS-REx practice sample collection. This image shows the sample site of the Nightingale crater. Here it need to be, you can say this is the crater right now, where this spacecraft just landed and collected the samples. Okay, this is the image of that, and this is the whole you can say the map of the asteroid Bennu. We have that world map here on Earth, right? This is like kind of a world map of this asteroid Bennu. You can see that here. This is this, and this famous NASA's OSIRIS-REx Hearts Bennu. This is a photo on the capsule. The return capsule, yeah, I think so, that is that. And I think the sun is shining in such a way that it is creating a heart-shaped kind of a thing on this spacecraft. This is kind of cool. And this is a 3D view of Bennu. Was created by Altimeter, yes, contributed by Canadian Space Agency. Just because of this contribution, we were able to get the 3D models. And Bennu in stereo. Okay, this thing is very cool, guys. As you can see here, some you can say material is being ejected from the asteroid. This kind of thing was not expected from the asteroid to be done, because they thought this is a dead asteroid, but after going to the Bennu, they found out no, it's an alive asteroid. The things are happening there, bombing and all things are happening. Okay, so this is the thing, and this is the return capsule in which the sample will be kept and returned to the Earth. So yeah. Yeah, this is the very cool image which I found, guys. You can see here the Earth and the Moon in just one picture, and you can imagine the distance also from there. Many people just kind of put Earth here and the Moon kind of very close to it, and but in reality, you can see the distance from the Earth and the Moon. That is huge, literally huge, and kind of cool also. And this is the view from the camera which took this photo of the Earth. The Jupiter image which it took. And okay, so that's yes, this is a successful, Andrew. And yeah, so let me just show you more cool images, not images. Now we can see the videos, maybe cooler videos. We already have seen these things. Any good thing? I don't know. No, we don't have that. No worries. So these are the instruments, guys. The TAGSAM here, the sample was collected. OVIS, OTES, Polycam, MapCam, SAMCAM. This is the SAMCAM here, which will basically image the sample. That's why SAMCAM. This is the MapCam, seeing at the map. And yeah, I think that's pretty much about it. Yeah, I think that's it. That's pretty much about it. So guys, yes, let me see if we have any update from NASA's for this, and I'll tell you if we have. Right now, so we don't have that thing, and yeah. Wow, so you can see so detailed version of this. Here are the thrusters, all the instruments and everything. Wow. So guys, if you want, do you want me to play Kerbal Space Program and maybe you can say kind of do something like that in the, if you want, or we can just switch the stream and go back to our work, because everything is successful and we don't have anything down. Oh, we can do, wait a sec. We just saw about OSIRIS-REx, right? We can have a look at other missions also. Let's just see where is Perseverance rover right now. Let's just see that. Here we have the Parker Solar Probe, Mars 2020. Let's just go. It's halfway through, guys. It's halfway. That's the Earth, that's the Mars 2020 over, and this is the Mars. This will basically come to Mars in around Feb. Yes, Feb. Sitting calmly and close in this heat shield. And yeah, these are the solar panels. And where are the thrusters? Yeah, there are the thrusters, guys, for the Mars rover. This is basically a kind of a service module in which you can see here. I don't know if it is supposed to rotate or not, but yeah, these are the solar panels here. These are the thrusters, if you are able to see it or not. These are the thrusters, and this is the heat shield. When it will come near the Mars, it will basically first of all inject it in the Mars orbit, and then it will deorbit basically to collide with, not collide with, to intersect with the Mars atmosphere. This will detach and that's a whole kind of a thing. Okay, let's have a look at other things which we have here. Guys, if you are new to this channel and want to have cool streams like this, because here we cover rocket launches, space events, everything live with you, everything in one stop. So you can consider subscribing and help me in buying one microphone. It's I know the audio quality is really very terrible. So if you want to support me, you can help me in that by just heading over to the Patreon. Link is down in the description, and supporting me to buy a microphone. So let's just have a look at the Parker Solar Probe. We have everything which NASA has launched. This is so cool. Yeah, here we go. This is the Parker Solar Probe. Well. I know what is this. This is a heat shield. I know what is this. This the solar panels, and where's the sun? But yeah, there's the sun. Okay. This is the magnetometer. Yes, this is a magnetometer. That's why it is extended so much far away. And the Parker Solar Probe was basically sent to study the sun, the solar flares, the solar winds, the corona. Yes, it also has corona. Basically, that's the surface is there. There is one, you can see the layer corona, and it has to study that, and basically it will be try to predict all the solar flares and everything that happens. So it is kind of cool. So let's have a look at some other thing. Voyager 1, where is the Voyager 1 and all those spacecraft? Here we go, the New Horizon, Voyager 2, Voyager 1, Pioneer 11, Pioneer 10. Here we go, the farthest spacecraft, the Voyager 1, which was launched in way back in 1970s, and it is still alive, and it is has crossed the solar system. Just saying bye bye. And everything in this Voyager spacecraft has been switched off. I don't think so they have anything on. Only thing which is on is the data which is being sent from it. And it is expected that also, yeah, one thing is to be noted, that it is so far away that one signal to go from Voyager to the Earth, it takes around 25 to 26 hours. Okay, just a signal, just a bit to go, and then from Earth to back to Voyager, it takes around 25 to 26 hours. So it is that much far away. You can't just do anything to it. It's really very far away. Kinda cool though. It basically had all the things that was famous in 90s from every nation. Basically, you can say, what should I say? A sign of humanity. That means a sign of life which is there. If this spacecraft goes to any other planet or collides with anything, and if there is some intelligent life there, so they can basically see and that yeah, there is something somewhere that intelligent life exists. So yeah, cool though. Yes, Andrew, you are right. It's a thank you. It's hard to build a project when you don't know it will work correctly for years. They have actually, you can say, invested 20 years in the making, and you know, they don't know if it will be successful or not. But yeah, that's the thing. Yes, Andrew, you are very right. Exactly. I can't believe it made it. I'm so happy. The quality control was very strict and we tried so hard on this program, and We made it. Waiting for the James, Karan says, waiting for the James Webb to get out there and kick some exoplanet butt. Yeah. It is launching on October 21. Oh yeah, it's it's just 1 year from now. On October 21, 2021, it will be launched. The James Webb Telescope, a $14 billion something. Okay, it's a very expensive material, and it will be launched from Ariane 5 rocket. And Ariane 5 rocket will be having very much responsibility to handle such an expensive payload, which had taken so many years, around 30 to 40 years in development. And it will be the most powerful telescope to have. And it is such a powerful and complex machine that to unfold everything and to configure itself in the you can say operational state, it will take 1 week to just unfold itself, getting everything ready. And yeah, it will take 1 week for that. So you can just imagine the complexity. If any complex material, the most complex material right now and the most engineered and you can say expensive material right now on Earth, I won't say, is the ISS, International Space Station. The most complex engineering solution, most expensive, and that. And after that, if I know anything, it will be this thing. That will be so cool. Okay, let's switch over to something else. What do you want me to do, guys? There's the thing which you can see here. I haven't seen Pioneer spacecraft. Oh, let's just over to planet. How will it? Oh, that's Jupiter for you. Downloading. Oh wow. Oh wow. Seriously, man. Wow. Jupiter is so pretty, man. Jupiter is so pretty. And in the orbit of Jupiter we have these, and obviously Juno spacecraft, which was sent to study Jupiter. As you can see, has very high elliptical orbit. And these are some moons of and the most important moon is this one, the Europa, which is you can say considered to have life, kind of life. If you play KSP, it is analogous to Lathe. So many scientists are interested in this moon of Jupiter. That's the thing. Let's hope over now. Waiting for these samples to arrive on Earth. Yeah, why only? Okay, so tell us why only 2013 to the James Webb Kepler owes its genes to Grandpa Kepler. Okay, 2023. Why it is 2023? Okay, so let me explain you guys that thing. So, okay. Did you ever thought why all the Mars mission which has been launched in 2020 amidst of pandemic? Why can't they just wait for this thing to over and maybe launch something someday else? Have you ever wondered? If you know all the Mars mission, there have been 3 Mars mission which have been launched. One from the NASA Perseverance Mars 2020 rover. The second is from China. I don't remember the name. Tuang-11, if I'm not wrong. And that is very ambitious mission. The China is going straight with the orbiter and the lander and the rover. Everything 3 in the one mission. And the UAE with their Hope Mars mission. All the 3 have been launched for today in this year. And yeah, Mars was closer because of orbit, and kind of thing you have said it right, but it wasn't closer, as you can see from the imagery here. Okay, let me just get back to it. And Where is Mars? Yeah, it is. Okay. Yeah. So as you can see, guys, if you can see from the image right now, you must be thinking it is closed. Like if we have launched from right now, if we have launched anything from Earth, it can go just straight here, straight to this thing, and the Mars will arrive. No, things does not work like that. Okay, if I can just revert the time from when it was launched, it would be great. Do I have the thing to revert? Okay, we can do that. Well, let me just set the time to when it was launched. In July it was launched, so yeah, kind of like here. So you can see right now the configuration. The Earth is here, the Mars is here, the Earth is here, the Mars is here, and it is not at all closer. The Mars should have been here from shooting something from Earth to Mars, but it does not work like that. As you know, we have this the Mars 2020 rover already there. So what we have done is this is what we called home and maneuver. Okay, so what we have done is we have launched the all the Mars mission from here on Earth at this point. So what will happen is this will go, the thing will go like here and intersect here. Can you see my mouse control or not? I don't know if you can see. Yeah, David L, it's a launch window. That's what I was trying to explain. So basically that's a home and transfer maneuver which it has performed, and it is necessary, not it has performed, not it is performed. Okay, yeah, it has performed home and transfer maneuver, it has performed, but home and trajectory is there, which is necessary because it ensures that we have the less amount of fuel used for the same destination. It is the most efficient way of getting to somewhere somewhere else in space. And why everything works like that, the answer is orbital mechanics, so I'm not getting deep into that. And yeah, the launch window is there. So the answer is 2021 is the launch window for the this Bennu, this OSIRIS spacecraft to depart from Bennu and then come to Earth. So since it took 2 years to get to Bennu, it will take 2 years. It does not work like that, but in layman terms you can understand it took 2 years to reach Bennu. It is taking 2 years again to reach Earth. So in 2021 it will depart, in 2023 it will come and we will get the sample. Okay, it's the launch window, because otherwise what will happen if we don't you can say depart at that time, somewhere around the line the Earth will be here and our spacecraft will be here. We won't be meeting, and then our spacecraft will just go like this and somewhat like this. So the Earth or the spacecraft will be left behind at the time of you can say intersecting the orbits, or the spacecraft is left behind. So weird kind of things happen. That's why launch window is a critical thing. Let's have a look at the Mercury. Really? No, I haven't imagined Mercury like this ever. Is it like this? Am I seeing Mercury only or the moon? I don't think so. Mercury does not have any color. Black and white. Oh, let me just confirm. Why am I like this? It is like that. Well, good. I didn't know. Wow, what the hell? How about it? So this is Mercury. Let's just go and see Venus. Yes, and yeah, this is Venus, but the color is kinda not correct here. But it is also a gas giant, and in this Venus only right now. In recent days, it was the thing where people were so excited with the phosphine discovery from the atmosphere, because it is believed that some life is there in the upper atmosphere, or the atmosphere on the clouds, you can say. Some life can survive on the clouds because there it provide habitable environment, and they didn't expected phosphine gas to be detected from Venus. And phosphine on Earth is considered to be a part of life. If life is there, then the phosphine is you can say is detected. So that's a big discovery, and ISRO is planning to launch the one spacecraft to Venus along with the France Space Agency to study Venus, obviously. Yes, David, Venus is not a gas giant, just have a very dense atmosphere, right? If you know, it's Eve in KSP, Eve. And what's this pizza? Yeah, I think it was the first telescope. Yeah. How can I forget? Yes, David, it crushed the probe that landed on a Venus after a few minutes. I think the Russians just got us a picture from Venus. Was it a video? I think it was a picture, and the pressure is so dense in Venus that everything just get crashed. And NASA is working to you can say, send a spacecraft to the land to land on Venus, and that's why they are thinking of they have invited applications to basically work in a, you can say, invited application to just think differently, that how can we survive on Venus, because here there no electrical equipments will work properly, which we saw from the Russians, which we learned from the Russians. So they have to be they have to just get back to old 90s and get back to all those mechanical computers. Okay, and they are just looking in ways to survive the Venus harsh environment and pressures and all. So Manat Singh, can you show us your face? It could happen once if I get something out of it. I don't have right now the webcam or the microphone. I just need to buy one to improve these things. We built OSIRIS Rex because I believe the project before it was supposed to collect dust from yes Andrew, you are right, and that was a Rosetta mission from European Space Agency. And thanks everyone, excellent work. Yes, it was tough, lol. So stupid to wear mask and no glasses, are standing apart like people who drive in their car with masks. Masks don't work, especially if you are not sick. Who and Dr. Fuji have stated. Yes, but it is basically a way of precaution, because the this COVID is asymptomatic in nature, and we also don't know whether we have COVID or not. So it's better to have precautions rather than just suffering from it. So cool, we'll be back to Venus one day, but first Mars. Okay, so this is the Spitzer Space Telescope. Launch date was 2003, I think, and after that the Hubble telescope was launched, if I'm not wrong. I don't know, I'm just can't remember the proper. Well, but it is very interesting thing to look in everything. Yeah. This is also a space telescope. Do we have okay, let me just see if what we have there. Near Earth. That would be great to see. What do we have here? So this is our Earth, US. Yeah, this is US, Africa, India, Australia, and yeah, and obviously the satellites. ISS. Do we have the picture of ISS also? Wow. Oh wow. Just look at the humanity's most expensive thing floating in space, and it's been floating since 20 years now. And right now we okay, so it has not been updated with all those things. There has been something docked. These are the radiator solar panels, and obviously this is an international collaboration effort. Will the Manat Singh says, will the Psyche mission collect some minerals like gold or platinum from the asteroid Psyche? Well, Manat Singh, right now I don't know much about the Psyche mission, but yeah, asteroid belt is really interesting also. I'm sure the team went through a billion check before making it in that room. Yes. Okay, come on. And I just we have so many satellites here, and I think this has only been the things which you are seeing is only of NASA's, nothing else. So do we have anything interesting to look at? You won't be finding Starlink obviously, so don't ask me to do that. But where is our pretty moon, Chandra? Okay, moon. Obviously at moon also we will have something, so let's just go to the moon. There we go. The lunar reconnaissance orbiter, where the Chandrayaan-2 also orbiting the surface. What else do we have? The Artemis phase 2. Oh, Artemis, they haven't launched anything, so do we have anything? This one is something else. Okay, what is this? There are so many things to explore and I don't know. Wow. Can I just zoom out of it, please? Or do I go back? Artemis P1, Artemis P2, that's all we have here. Make home. Okay, so guys, it's okay, it's all right. Now I am just playing around and everything. So guys, if you have any questions to ask, you can just ask me and I'll try to answer if I can. Space mining makes sense. Thank you, Karan. Okay, the new plan is to push the asteroid into our ocean. Rocket boosters push hard enough. Mr. Sandman says that. if we can push the asteroid, then we would certainly push it away from Earth only, not into our oceans. Can you please show us where is Perseverance? Okay, I'll do that. It will land in Pacific Ocean. Okay, let me just show you the Perseverance once again. I just did that, but okay, no worries, I'll show that again. Why can't I see that now? Okay, so yeah, I have to roll out to right now. Yeah, here we go. With the Perseverance. The space mining makes sense. Vincent says space mining makes sense for space infrastructure, so it needs to be done. But would probably be prohibitively expensive to bring a large enough amount of resources back to Earth. Yes, that's what they have to figure out, because it's not a deal breaker. It's $1 trillion economy which you can do. You can be a trillionaire, so it's not a bad thing to do, but obviously it will be very, very costly. So you just need to figure out how to bring down the cost. Manat Singh says, why ISRO uses hypercolic fuel for their rockets? Because it is toxic and it can harm animals and environment. Okay, yes, you are right, it is toxic, Manat Singh. But the thing why does it use is because it is simple. Okay, right now the engine which ISRO uses is the Vikas engine, and it is a relatively simple engine, and it was derived from the Viking engine of Ariane. Yeah, so it is derived from that, and it works on hypercolic fuel only. It is relatively simple to make because you don't need any igniter. Hypercolic fuels are basically those fuel which just upon mixing they ignite and start burning. So it's basically a simple design to make, so that's why. But no worries, they are just making right now, developing a methalox engine also, which will work on methane and oxygen, and obviously we have the cryogenic engine also which works on hydrogen and oxygen. So that's why, that's the thing. The position of Perseverance, you can say here, guys. Here it's you can see Earth is here, Mars is here, and if you just want the coordinates, that would be very technical, but you can see here, and it will meet the Mars. If I just go ahead, you can see, just see how it is moving and arrive on Mars, arriving, and let's go closer to that. That's the Mars. Let's go more closer. Whoa. Have we missed it? I think so. Yes, we did. But it's okay, no worries. Why not space miners mine the moon? Yes, it is in the making, Mr. Sandman. The space miners, the first target is the moon only because it is relatively easy, and also people and NASA and countries are basically pushing to just stay on moon, so it will be a very good thing to mine that. So yeah, they are considering that. It will Karan Pradhan, it will devalue all of the Earth's currencies. That is the debatable question, Karan Pradhan, and people are just debating on that. But first of all, just develop the technologies and then debate. I just believe on that. Hypergolics are storable and safer to handle. Yes, that's one more reason, and easier to use. Also extremely toxic and cancerous. Yes, exactly. So guys, I think it will be enough. Let's go back to Bennu once again and see. that should be enough for today. And what makes asteroid moves? We just do what they are doing. Okay, so it has some scientific significance. Why do they move? Where is the sun? I mean, I'll tell you why do they move. As you can see, the sun is here, asteroid is here. So this side of asteroid will get really hot because the sun is it is facing the sun side, and this side will be very cold because it is not facing the sun side. And because of this fluctuation in temperature, we have seen one effect in which these asteroids tend to reflect these radiation away from the surface, and because of that its orbit gets changed because it works like thrusters. When heat strikes the surface and gets away, the radiation itself acts like a thruster, because this is a very small object in considered to planets. It's a small object, so this phenomena is there. It has some technical name, also some Russian name, I don't remember, but yeah, that's why their orbit changes. Why ISRO is making SSLV? Because PSLV without strap-ons can also put lightweight base satellites to low Earth orbit. That's a good question, Manat Singh. ISRO is making SSLV because it is a smaller one and it can be assembled in 30 days. No, 30 days can be 30 days is the turnaround time for PSLV, but the SSLV can be assembled in just a week. It is cheaper to make, and also it requires only 6 to 7 officials to make. The PSLV requires many more complex things, so that's why. What makes asteroid move? Okay, if everyone becomes a billionaire, then no one will be. Obviously. Wish you could ditch the music, though I'm hearing the deficient and having trouble here. Okay, so okay, no worries, I'll do that. It should be good now. Should be good now. And so I think we don't have anything else to do right now, but I can just talk about space and everything. If you can go on talking, I'll also go on talking. So it depends on you if you want me to just be here or go away. Will compressed air jetting out push stuff? Yes, it does, because it works like a reverse vacuum, and I have shown that phenomena a number of times. How does that work? So yeah, I think this is the high gain antenna and this is the low gain one. I don't know anything about it. Yes, vocals, I did lower the volume of the music. So guys, I think that would be enough for today, and congratulations NASA for your successful touchdown and collection of the sample. And I now hope that that collection is successful and we do have a proper amount of sample in place so that we can just send it back to Earth. I'm so much excited. I was so excited, and finally we could have that. So yeah. So do we have any other update from NASA? Let me just see. Obviously, Jim Bridenstine is there to congratulations to the entire team of OSIRIS-REx and all of NASA's partners on this mission. We are on the way to returning the largest sample brought home from space since Apollo. If all goes well, this sample will be studied by scientists for generations to come. Yes, 75% of the sample will be preserved for the future generation. Why? Because the future, obviously, we know that we will develop some technologies that we don't have right now. So that technology will be able to better analyze that sample, and yeah, that's the thing. Have you heard of SpaceX? Yeah, guys, I host every rocket launch that happens in the space industry, whether it be from US, China, Russia, Japan, Israel also, or whatever, and whether it be private or anything, any rocket launch that happens, I host that on this channel only with the live stream with you guys. So just subscribe and hit the like button right now and support me on Patreon if you can. I really need your support, guys, to buy a good microphone because I need to improve the audio quality. Have you heard of space reusable rockets and SpaceX? SpaceX is the company which has revolutionized the space sector. I'm literally so much admired with SpaceX and Elon Musk. I just can't tell what it is. Basically, they have achieved something which even the government agencies have achieved. I'm so much happy that private company has done that. They have done reusable rocket. They have made a rocket. Their first driver rocket was so big, means it could put 222 tons into low Earth orbit, and there are countries which does not even have that capacity with the government space agencies. So it's a very big achievement for SpaceX. I really admire Elon Musk and his company. And obviously the reusable rocket is the first and the right now the only operational reusable rocket which is being placed. And yeah, thanks Karan, thanks for your appreciation, really appreciate that. Minimum 60 gram solar panel batteries and air compression is the way to space. Solar panel batteries, I and the air compression, no, it does not work like that, Sandman. uh, you can say that if you want to you can say uh, go in space and do space travel. Maybe the proper word would be space sail, oh sorry, the sun sail, the solar sail. Yes, the solar sail. Like we have a sail for the boats on Earth, that sail is done by air, right? The solar sail will be the solar, as the name suggests, everything will be done by the solar winds and the solar radiations coming. There will be this is a concept, it has not been demonstrated yet, but this is a concept wherein there will be a very large sail from which the solar radiations will hit it and push the spacecraft or whatever it has, push it away from the Earth or whatever way, wherever it has to go. So it will be a way of travel in space, and it won't be require anything to do. But yeah, you need to control, as in how do you control the direction and how much burn do you want or whatever like that. But that would be a question. What is the single most important thing they hope to find from the Bennu samples? Lloyd, basically there is three things which they want. Which why? First of all, there are three things why they have chosen Bennu in first place. First of all, is the origin of life, because we believe that asteroids are the, you can say, the mother of every human being on Earth or every living creature on Earth, because it is believed that it has been said that asteroids were the one who brought life to Earth. So, and this asteroid Bennu is 4.5 billion years old. So there comes the second point. So it can prove, you can say, when we are looking at Bennu, we will be looking at the baby pictures, as they said, the baby pictures of the solar system. That's why they went there. And obviously, the third reason is, which I find very fascinating, is that it is a hazardous asteroid to the Earth, and they want to study it so that if any future in future, if it is in collision trajectory with Earth, so that it can redirect and change its orbit and hopefully save humanity and change our destiny. We don't want to live and die like dinosaurs, right? We are humans and intelligent species. So if we can do something, we will do something to save humanity. It will just imagine that day when, if some I don't want to experience that day, but that if that unfortunate day, if we got to know something like that, NASA announced that there is one asteroid which is in collision trajectory towards Earth, and we don't know if we will live or not. Right now, whatever asteroids have been there, they have just flown by the Earth. They haven't hit the Earth right now. But there must be some asteroid which is right now in collision trajectory towards the Earth, and we don't know it. And if we just know it before and we have the technology, then we can just go and change the orbit and save humanity. That will be like Avengers movie scene. It will be very sci-fi movie scene, but yeah, that is possible. So the single most important thing they hope to find from the Bennu sample is the origin of life and the solar system. They have two basically uh, motives: origin of life, if they have any life on asteroid, water, because there is water crystals on asteroid, and we will be looking at the baby pictures of the solar system. That's the thing. I will make my own rocket and spaceship. Best of luck to you, Mr. Sandman. Ride sharing option, looking for exotic vacation and this. Okay, just sign up. Okay guys, thank you so much for tuning in, really appreciate that. So in conclusion, if I want to say, we just tuned in and I just explained everything about Osiris Rex. What is it, why is it, and why we are going there, what it is Osiris Rex, and this spacecraft, this tag, this Bennu, everything. And finally the great show from NASA, basically seeing everything, getting us to know that this thing has actually touched down, taken the samples and gotten back. That is very emotional for those people, and for me also, a true space lover. So that is it for today guys. Tomorrow we have one other stream guys. The SpaceX will be launching the Starlink satellites, so I'll be streaming that. We have two launches tomorrow. SpaceX Starlink, no, the SpaceX Starlink or what, yeah, if it is Starlink or not, but SpaceX is launching one, and we have Rocket Labs launch also. I'll be streaming that also. Just stay in for that. Subscribe this channel. I'll just post the images or the videos, whatever comes from the NASA, to this channel only. So just like this stream, subscribe to this channel, and support me on Patreon if you can. And guys, thank you so much for tuning in. If you like my work, you can support me. Thank you so much. Till then, this is Rocket Gyan. You just saw Rocket Gyan. Okay, let me just this was not what I say. Okay, so until then, you just saw Rocket Gyan. This is Priyanshu Roila signing off. Stay safe, stay healthy, and bye bye.